cosm. Whoosh.
Imagine, for a moment, standing on the edge of the cosmos. Out there, beyond the galaxies and clusters, beyond the nebulae where stars are born and the supernovae where stars die, the universe hides secrets that even our most advanced telescopes can barely whisper about. Among these mysteries, one idea stands out as both breathtaking and terrifying. A possibility that what we think of as the ultimate cosmic predator, the black hole, might not be the final word in astrophysical horror. That there could exist something stranger, something deadlier, and perhaps something far more unsettling: the gravastar. When we talk about black holes, we imagine regions of space so warped by gravity that nothing, not even light, can escape their grasp. A place where the fabric of space-time collapses into an abyss, and at the center, a singularity, an infinitely dense point that defies the laws of physics. For decades, black holes have reigned as the dark kings of the universe, objects of both fascination and fear. They shred stars apart, bend light like taffy, and distort time itself. Yet, even as terrifying as they are, black holes are built on mathematics that break down at their very core. And whenever science meets infinity, nature often has a way of surprising us. Now, imagine an alternative. Picture a cosmic object born from the same violence that gives rise to black holes, but one that takes a different path. A place where the collapse of a massive star halts not at a singularity, but at a boundary where exotic physics intervenes. Instead of a point of infinite density, you find a hollow shell, a sphere of ultra-condensed matter surrounding a core not of crushing gravity, but of dark energy itself. This is the gravastar, short for gravitational vacuum star. To call it bizarre is an understatement. To call it dangerous might not even begin to cover it. The idea was first proposed in the early 2000s by physicists Powell Mazur and Emil Motola. They suggested that maybe, just maybe, the universe is not fond of infinities. Instead of allowing a star to collapse into an impossible singularity, nature might insert a loophole. In this loophole, the core of the collapsing star is replaced by a bubble of dark energy, surrounded by a thin but incredibly dense shell of matter. On the outside, it would look almost identical to a black hole. Its gravitational field would bend light in the same eerie ways. Its shadow would appear just as dark, its presence just as menacing. But the inside would be something else entirely. Here's where it gets disturbing. While black holes consume everything that crosses their event horizon, gravastars might operate differently. Their shell of exotic matter could act almost like a cosmic mirror, bouncing infalling material away in ways we don't yet understand. Some models even suggest they could erupt violently, spewing radiation or matter back into space. Others imagine them as silent traps, luring matter into their vicinity only to unleash catastrophic bursts when that shell destabilizes. Unlike black holes, which are at least predictable in their relentless hunger, gravastars are a question mark. And in astrophysics, a question mark often translates into danger. Think about what that means. For decades, astronomers have been mapping black holes across the sky. We can identify their mass, estimate their spin, and even now, with the Event Horizon Telescope, capture images of their shadows. But if gravastars exist, if even a fraction of those supposed black holes are imposters, then we might be misreading some of the most fundamental structures of the universe. We may be staring at monsters wearing masks. What makes gravastars especially chilling is the role of dark energy at their core. Dark energy is the mysterious force driving the acceleration of the universe's expansion. It is, quite literally, the energy of nothingness, a pressure that seems to push space-time apart. If a gravastar is powered by this vacuum energy, then inside its hollow heart lies a pocket of the same force that is shaping the destiny of the cosmos. To encounter such an object isn't just to brush against gravity gone wild. It's to brush against the engine of cosmic acceleration itself. The implications are staggering. Could gravastars grow by siphoning this energy? Could they destabilize? Could they collapse or explode in ways that release unimaginable power? In a way, gravastars are even more terrifying than black holes because they challenge our sense of certainty. With black holes, as deadly as they are, we at least have rules. They eat, they grow, they evaporate slowly through Hawking radiation. Their mathematics is extreme, but it's a framework we can work with. Gravastars laugh at our frameworks. They are born from the places where quantum mechanics and general relativity collide, where space-time itself becomes unpredictable. To study them is to step into a domain where our most trusted laws falter, and where nature might be hiding its most explosive tricks. Imagine an advanced civilization orbiting near what they believe is a black hole. They've built their science around it, charted its gravity, planned their starships to avoid its maw. But one day, instead of quietly feeding, the gravastar detonates, its shell rupturing like a cosmic supernova, blasting radiation and shockwaves across light years. Such an event could sterilize entire star systems, wipe clean the galactic neighborhood, and leave behind a silence deeper than death. As unsettling as this sounds, it also raises a thrilling possibility. Perhaps we've already seen hints of them. Across the universe, astronomers detect gamma-ray bursts, colossal eruptions of energy so bright they can outshine galaxies for brief moments. Their origins remain mysterious. Some come from merging neutron stars, others from collapsing hypergiants. But could some be the fingerprints of gravastars? Could their unstable shells produce bursts that mimic these cataclysmic signals? It's not an answer we have yet, but it's a question we can't ignore. So why should this matter to us here on Earth? Because the universe is not a distant theater. It's our home. Every time we uncover a new type of cosmic object, it reshapes how we understand our place in the grand story. Gravastars, if real, would force us to rewrite our textbooks, reconsider the end states of stars, and confront the idea that nature may prefer strangeness over simplicity. For us as a species, grappling with such discoveries is more than scientific curiosity. It's survival, it's preparation, it's the recognition that the universe still holds cards it has not yet shown. And maybe, just maybe, the most terrifying monsters are not the ones we already know, but the ones we've only just begun to imagine. If gravastars exist, then they represent one of the boldest rewrites of cosmic storytelling. For decades, we have been told a simple narrative. Massive stars end their lives in collapse, creating neutron stars or black holes. The finality of it seemed almost poetic. Black holes, in particular, became symbols of inevitability, the ultimate full stop in the grammar of the universe. But gravastars whisper that nature may not be so straightforward. They suggest a plot twist. The universe may not favor infinities. It may choose balance instead of paradox, even if that balance looks nothing like anything we've ever encountered. What makes gravastars so haunting is their invisibility within our current tools. To a distant observer, they would mimic black holes almost perfectly. Their gravitational pull, their light-bending signatures, their silhouettes against the cosmic backdrop, all would appear the same. If the Event Horizon Telescope trained its gaze on a gravastar, it might still reveal a dark shadow wrapped in glowing plasma, indistinguishable from the one we've seen around the giant in M87. To the human eye, they hide in plain sight, and yet, behind that mask lies a radically different engine. So how could we tell the difference? This is where astrophysics becomes detective work. One clue may be found in the way matter behaves as it spirals inward. Around black holes, infalling matter heats up and emits X-rays as it approaches the event horizon. The light dims and disappears once it crosses the boundary. With gravastars, however, there is no true horizon, just a thin, ultra-dense shell. Matter might bounce, accumulate, or even ricochet, creating emissions that deviate subtly from the black hole template. Detecting such nuances requires not just telescopes, but patience, precision, and a willingness to question the assumptions baked into decades of observation. Another clue might lie in gravitational waves. When black holes merge, they produce ripples in spacetime that LIGO and Virgo have now detected dozens of times. These signals have a specific ring-down pattern, like the fading vibrations of a struck bell. But gravastars, if they collide, might leave behind echoes. Their hollow interiors and elastic shells could cause spacetime to reverberate differently, producing faint aftershocks in the gravitational wave signal. Already, some researchers are combing through LIGO's data, searching for these echoes. Nothing has been confirmed yet, but if they are found, it would be one of the most revolutionary discoveries in physics. And then there's the question of stability. A black hole, for all its horror, is remarkably stable. It sits, it feeds, it grows, and over eons it slowly evaporates. Gravastars, on the other hand, might not enjoy such long-term equilibrium. If the shell destabilizes, the trapped dark energy at their core could erupt outward, unleashing explosions of energy we can hardly imagine. This makes them not just exotic, but potentially catastrophic. A gravastar on the brink might be a ticking time bomb, waiting for the smallest perturbation to trigger a cosmic blast. The mere possibility of gravastars also forces us to re-examine what we know about space-time itself. At their heart lies vacuum energy, the very same dark energy, accelerating the expansion of the cosmos. This suggests that the building blocks of gravastars are tied to the destiny of the universe itself. Imagine that stars that collapse not into singularities, but into tiny laboratories of cosmic acceleration. If that is true, then to study gravastars is to study the same physics that will determine how the universe ends. Will it expand forever into an icy void? Will it tear itself apart in a big rip? Or could gravastar-like objects eventually dominate, altering the balance of matter and energy on the grandest scale? It's worth pausing here to reflect on how strange this all sounds. For centuries, humanity has chased the frontier of the unknown. We feared comets as omens, only to learn they are icy travelers from the solar system's edge. We feared supernovae as cosmic disasters, only to discover they forge the elements that make life possible. Black holes once seemed like abstract mathematical curiosities, until they became pillars of astrophysical reality. Gravastars may follow the same path. First speculation, then skepticism, and perhaps one day confirmation. And if that confirmation comes, it will rank among the greatest upheavals in scientific history. But beyond the science lies something deeper, the philosophy of cosmic identity. Black holes embody finality. They tell us that everything, no matter how grand, can fall into silence. Gravastars, in contrast, represent ambiguity. They blur the line between creation and destruction. They embody tension, a fragile balance between collapse and expansion, between gravity and dark energy, between the known and the unknowable. If black holes are the cosmic graveyards, then gravastars may be something stranger, vaults holding the very fuel of the universe's expansion. Consider what this means for the story of stars themselves. A star's life is a balance between gravity pulling inward and nuclear fusion pushing outward. When fusion ceases, gravity usually wins, collapsing the star into a white dwarf, neutron star, or black hole. But gravastars hint that collapse may not always be absolute. That under certain conditions, the universe might replace singularity with symmetry, trading infinity for vacuum energy. This is more than physics. It is a lesson in nature's creativity, a reminder that even in death, stars may be transformed into forms we have not yet fully conceived. And in a way, gravastars reflect us, too. Humanity has always sought boundaries, the edge of the map, the bottom of the ocean, the limits of the atom. Each time we found not endings, but beginnings. Gravastars, if real, are not the end of the story of gravitational collapse, but the beginning of a deeper one. They ask us to reconsider what we think we know, to question the inevitability of singularities, and to accept that the universe may prefer mysteries over conclusions. As we peer deeper into the cosmos, building more powerful telescopes and detectors, the truth may reveal itself. Perhaps the next gravitational wave we capture will carry an echo, a whisper from a gravastar's hollow core. Perhaps the next gamma-ray burst will betray an instability too wild for any black hole to explain. Or perhaps, in the end, we will discover that gravastars do not exist, that nature has chosen black holes after all. But even that would teach us something invaluable, that our willingness to imagine alternatives was not wasted, but essential. For in science, every path explored brings us closer to understanding. And so, gravastars remain both a scientific speculation and a cosmic metaphor. They remind us that the universe is not obligated to be simple, nor is it bound to obey the neat categories we invent. It may offer us black holes with their relentless gravity, or gravastars with their hollow hearts of dark energy. It may give us objects that straddle the line between destruction and creation, daring us to look deeper, to listen harder, to wonder more profoundly. For in the end, the greatest terror is not the monsters we see, but the possibilities we cannot yet prove. Gravastars may never reveal themselves, or perhaps they already have, hidden behind the shadows of the cosmos, waiting for us to notice. And when we finally do, the story of the universe and our place within it may never be the same. In every age of science, there are objects that serve as riddles. They sit at the edges of our knowledge, half hidden, daring us to notice their strangeness. Gravastars belong to this category, not yet proven, not yet dismissed, suspended in that space between theory and discovery. They are not simply an astronomical idea. They are a test of how far our imagination is willing to stretch when confronted with the unknown. What makes the pursuit of gravastars so fascinating is that the very tools designed to reveal them also conceal them. Our telescopes show us shadows, silhouettes carved by gravity itself. They do not show us interiors. When the Event Horizon Telescope captured the glowing ring around the supermassive object in M87, the world celebrated a triumph of physics. Yet, that very triumph highlights our limitation. We saw the outline, the stage curtain, but not the actor behind it. A gravastar, dressed in the same gravity as a black hole, would fool us entirely. To distinguish one from the other, we need to become not just observers, but detectives of the invisible. This is where the future of astronomy enters the stage. The James Webb Space Telescope, already rewriting our understanding of the early universe, may provide subtle hints. Its infrared eyes can watch the faint flickers of accretion disks, the glow of matter spiraling near the edge of oblivion. If any of those signals deviate, if light lingers where it should vanish, if echoes bounce when silence is expected, then perhaps we are glimpsing the fingerprint of a gravastar. And beyond Webb lies the next generation. The extremely large telescope in Chile, the Laser Interferometer Space Antenna in orbit, and projects still on the drawing board, born from dreams as audacious as the stars themselves. Each of these instruments is not just a window but a challenge, asking, do you have the courage to see what does not want to be seen? The search is not purely technical. It is philosophical. Gravastars force us to ask a fundamental question. Does nature prefer symmetry over singularity? A singularity is, in many ways, a confession of failure. It says our equations cannot handle the truth at the deepest depths. A gravastar, by contrast, is a reconciliation. It suggests the universe does not need infinities to exist. It needs balance. A hollow center filled with vacuum energy, a shell dense enough to withstand collapse, an equilibrium forged not in harmony, but in tension. To discover such objects would be to learn that the cosmos itself seeks compromises where our mathematics reaches its limits. And this leads us to a darker thought. If gravastars exist, are they more common than black holes? Could it be that many of the black holes we've mapped in galaxies across the sky are imposters? If so, our census of the cosmos is wrong. Our understanding of galactic evolution is skewed. Even our theories of cosmic structure may need to be torn down and rebuilt. To replace black holes with gravastars is not to swap one monster for another. It is to rewrite the story of how the universe grows, one collapsed star at a time. Consider, for a moment, the role of energy in this tale. Dark energy is the great puppeteer of the cosmos. It stretches the fabric of space-time, pushing galaxies apart, accelerating expansion with a force that seems to arise from the vacuum itself. To find that same energy trapped inside gravastars would be to realize that stars can die not by collapsing into silence, but by giving birth to bubbles of expansion within themselves. The paradox is staggering. Inside the densest shell in the universe lies not matter, but emptiness with power. A gravastar would be a star turned inside out, its strength not in what it contains, but in what it lacks. From this perspective, gravastars become more than astrophysical curiosities. They become metaphors for the universe itself. They are masks, disguises the cosmos wears to hide the instability at its core. On the surface, they look like black holes, simple and final. But inside, They hold contradictions, voids, pressures that defy common sense. To confront them is to confront the idea that reality is layered, and that what we see is often a costume for something stranger. But perhaps the most unsettling implication of gravastars lies in their potential behavior. A black hole is predictable. It obeys a set of laws we grudgingly understand. A gravistar, by contrast, could surprise us. If its shell cracks, if its vacuum core destabilizes, the resulting eruption might dwarf supernovae, rival gamma-ray bursts, and unleash devastation across light years. A single rupture could sterilize planets, disrupt star systems, and echo through the galaxy as a warning of what happens when cosmic balance fails. In this way, gravastars are not just hidden. They are dangerous precisely because they pretend to be something else. And yet, the danger is also the wonder. Because if gravastars exist, they give us the opportunity to study dark energy in miniature. Instead of waiting for the universe to expand for billions of years, we could probe its workings inside these objects right now. They would be natural laboratories for the most profound mystery in modern physics: why the universe accelerates. To peer into a gravistar would be to peer into the mechanism of the cosmos itself. That alone makes them worth the search. So where does this leave us? On a cosmic stage where black holes, once the ultimate monsters, may only be one act of the play. Behind them, gravastars may lurk, more complex, more volatile, more connected to the universe's fate than we ever imagined. The challenge is not only to detect them, but to accept what they mean. That the universe is under no obligation to give us clean answers, that it prefers ambiguity, masks, and paradox. When we finally learn whether gravastars are real, the impact will not be confined to astrophysics. It will ripple into philosophy, into culture, into the way we think about endings and beginnings. If black holes taught us that even light can be imprisoned, gravastars may teach us that even death can contain the seeds of expansion. In their dark silence, they carry a message: that the universe is not a story with neat chapters, but an improvisation, a symphony of unknowns, always shifting, always daring us to listen closer. And as we gaze into the night sky, into the places where stars collapse and vanish, we might ask ourselves a final question. Are we looking at graves, or are we looking at disguises? If gravastars are real, then perhaps the universe has been wearing a mask all along. And perhaps the most terrifying revelation is not that monsters exist, but that they are hiding in plain sight, waiting for us to finally understand the performance. The story of gravastars does not end with their mystery. It expands into the destiny of the cosmos itself. For if these objects exist, then they are not just peculiar alternatives to black holes. They could be architects of the universe's future. Their interiors are filled with the very energy that pushes galaxies apart, and their existence might shape the balance between matter, and dark energy on scales far beyond human comprehension. To understand their potential, imagine the far future. Stars have burned out, galaxies have dimmed, and the universe drifts toward its cold, inevitable expansion. In this cosmic twilight, black holes are often imagined as the last rulers, silent giants devouring the remnants of creation. But if gravastars are real, then the endgame changes. Instead of singularities evaporating slowly through Hawking radiation, we might have hollow shells containing pockets of vacuum energy, persisting far longer than any star. Could these gravastars outlast black holes? Could they dominate the late universe, becoming the final structures of reality? Consider their possible life cycle. A gravistar might begin as a collapsing star that halts just before singularity. Its dense shell stabilizes, its hollow heart fills with vacuum energy, and it rests in a precarious balance. Over billions of years, that balance could shift. Perhaps the shell accumulates more matter, becoming denser and more fragile. Perhaps the vacuum energy within grows unstable. At some tipping point, the gravistar could rupture. And when it does, the release would not simply be an explosion. It would be a localized expansion of spacetime itself, a miniature echo of the Big Bang. This idea is staggering. It suggests gravastars might not just be cosmic corpses. They could be seeds of creation. Each rupture could spawn new physics, new regions of spacetime, even new universes budding off from our own. In this sense, gravastars become not merely endpoints but gateways, places where the cycle of destruction and creation are entwined. If so, then hidden behind their dark shells lies the possibility of cosmic rebirth. From a human perspective, this transforms them into both threat and opportunity. To a nearby civilization, a gravastar eruption could be an extinction-level event. The energy released could sterilize entire systems, tearing away atmospheres, boiling oceans, and reducing worlds to cinders. Yet, to an advanced species, the same object could be a source of power beyond imagination. The vacuum energy within a gravastar is not a trickle. It is the very fuel of cosmic acceleration. If harnessed, it might power civilizations for eons, sustaining them long after ordinary stars fade. Gravastars may be, paradoxically, both doomsday machines and engines of survival. And this leads us into the question of detectability. If gravastars truly contain pockets of vacuum energy, then their presence might ripple into the cosmos in subtle ways. They might distort the cosmic microwave background, leaving faint fingerprints across the afterglow of the Big Bang. They might alter the distribution of galaxies, introducing anomalies in the large-scale structure of the universe. If so, then perhaps we've already seen their signs, buried in the data waiting for interpretation. The universe may have been whispering gravastars into our instruments all along. Their existence also raises profound questions about time. In the presence of intense gravity, time dilates. In the presence of dark energy, time stretches. A gravastar combines both, a dense shell warping spacetime and a vacuum core pushing it outward. To fall into such an object would be to experience a war between two clocks, a conflict between timelessness and acceleration. For a human observer, this paradox would be fatal. For a physicist, it is the ultimate laboratory. Inside gravastars may lie the answers to questions Einstein and Hawking could only dream of. What is the true fabric of time? Can the expansion of the universe be reversed? Does reality allow bridges to new dimensions? From this vantage, gravastars transform into philosophical provocations. They remind us that endings may not be absolute, that death may contain new beginnings. If a black hole is a grave, a gravastar may be a chrysalis, dark, silent, and filled with hidden transformation. And if they dot the universe in numbers we do not yet realize, then perhaps the cosmos is not winding down into entropy, but constantly preparing for metamorphosis. Imagine, for instance, the ultimate fate of our own galaxy. In the distant future, the Milky Way and Andromeda will collide, their stars scattering, their black holes merging. But what if some of those supposed black holes are gravastars? Their collisions would not simply warp spacetime. They might unleash bursts of vacuum energy, reshaping the very fabric of the merged galaxy. Such events would not just be cosmic fireworks. They would be acts of creation, altering the destiny of billions of stars and planets. And perhaps this is the greatest terror of gravastars. Not that they kill, but that they change. Change is harder to predict than destruction. A black hole swallows. A gravastar may swallow, reflect, or explode. It may collapse into something we do not yet recognize. In this unpredictability lies the true danger and the true wonder. The universe has always been a theater of transformation. Atoms form stars, stars form heavier elements, supernovae scatter them into space, and from that dust, life emerges. Gravastars, if real, may be another act in that cycle, one we have not yet fully recognized. They are reminders that even in the darkest corners of space, there may be more than silence. There may be seeds waiting. And so, as we point our telescopes outward, as we listen for gravitational whispers and watch for bursts of inexplicable light, we should remember this. The universe is not obligated to keep its secrets simple. Gravastars, with their hollow hearts and fragile shells, are a message from the cosmos itself. A message that the story is always stranger, always richer, always more dangerous than we expect. In the final measure, whether gravastars are myth or reality, they serve their purpose. They stretch our imagination, they sharpen our science, they remind us that what we call knowledge is often just the scaffolding of deeper mysteries. And if one day we confirm their existence, we will look back at this moment, the moment we dared to imagine them, and realize that wonder is the first step toward truth. The night sky is full of disguises. Stars sparkle as if eternal, yet each one hides the certainty of its own death. Nebulae glow as colorful clouds, but inside them chaos reigns. Turbulence, collapse, and violence that will one day ignite into new suns. Even galaxies, majestic spirals and photographs, are merely moments in cosmic evolution, destined to merge, distort, and eventually fade. The universe has always been a master of masks. Gravastars may be the most elaborate masks of all. To our instruments, they masquerade as black holes, cloaked in shadows, their gravity warping light in familiar patterns. But beneath this costume lies something stranger. A hollow chamber, a bubble of energy that doesn't belong to matter but to the vacuum itself. It is as if the cosmos has taken the darkest symbol we know and hollowed it out, replacing the crushing singularity with emptiness that has weight, silence that has power. Gravastars are performances of reality, rehearsed with the precision of mathematics and staged with the drama of stars. If black holes are the universe's exclamation points, final and absolute, then gravastars are question marks. They leave us hanging, unsettled, staring into the unknown with the uneasy suspicion that what we believe is only half the story. And this uncertainty may be the most terrifying feature of all. For humans fear not only what is deadly, but what is undecidable, the ambiguity that lingers when no answer feels safe. There is something almost theatrical about the very structure of a gravastar. A dense, thin shell encasing a void of dark energy. It resembles not so much a tomb as a stage curtain. Beyond it, we cannot see, but we can imagine. And what we imagine may be even stranger than what truly exists. Some physicists suggest that the interior could act as a different spacetime altogether, a pocket where the rules shift, where distance and time flow in alien ways. To cross that threshold, if such a crossing were possible, might not mean entering a destructive abyss, but stepping into an entirely new realm. In this sense, gravastars resemble portals more than prisons. This image is both haunting and exhilarating. What if gravastars are gateways, not just objects of collapse, but thresholds to other domains of reality? Science has long speculated about wormholes, about bridges between distant parts of the cosmos, even connections to parallel universes. Gravastars may be nature's attempt at something similar. Their hollow hearts could be cradles of exotic geometry, places where expansion and contraction wrestle endlessly, opening cracks into what lies beyond. To contemplate this is to place ourselves at the border of myth and physics, where the universe begins to look less like machinery and more like story. Yet the danger is never far. A gravastar does not need to be a portal to be terrifying. Its very existence challenges the foundation of predictability. Civilizations that chart their skies, mapping the silent giants they believe to be black holes, might be living beside a disguised threat. To orbit such a being would be to rest beside a fault line in spacetime, never knowing if the shell will hold, if the void within will remain silent. It is one thing to know a predator. It is another to wonder if your predator is something else entirely. And here lies the paradox. Gravastars embody both fear and hope. Fear because their instability could rewrite the fate of entire star systems. Hope because their connection to vacuum energy offers a key to the greatest riddle of all, why the universe accelerates. If we could study them directly, if we could understand the strange balance they embody, we might uncover insights not only into their nature but into the fate of everything. Perhaps in their hollow silence lies the blueprint for the universe's expansion, and by extension, for its eventual end. Imagine the poetry of this, that the very objects which mimic death may in fact carry the secret of eternal birth, that what looks like a grave could be a womb. Gravastars are metaphors written in physics, poems carved into spacetime itself. They remind us that the cosmos does not conform to human comfort. It does not simplify itself for our convenience. Instead, it presents us with riddles, black holes, dark matter, dark energy, and sometimes it invents disguises so elaborate we mistake one for another. This raises a deeper question. Do gravastars exist only out there, among the stars, or do they also exist within our ways of thinking? They are symbols of humility, reminders that even the concepts we call ultimate may have layers we cannot see. Just as a black hole seemed once to be the end of the story, only to be followed by the speculation of gravastars, perhaps every conclusion in science is but a mask waiting to be lifted. In that sense, gravastars are not only astrophysical possibilities. They are metaphors for knowledge itself, hollow places where answers are not what we expect, but something stranger, something more profound. When civilizations look into the night sky, they see mirrors of themselves. Ancient peoples saw gods and heroes in constellations. Today we see physics and equations. Tomorrow we may see gravastars, and in them we may recognize not only the power of the cosmos, but the fragility of our own certainty. They are warnings that the universe is never finished with us, never done surprising us, never tired of reminding us that awe and fear are two sides of the same experience. And perhaps that is their true lesson. Gravastars are not merely deadlier than black holes because they might explode or destabilize. They are deadlier because they kill our illusions. They strip away the comfort of believing we know the rules. They remind us that the cosmos has always been a theater of mystery, where even the darkest shadows may conceal not endings, but new beginnings in disguise. So the next time we gaze into the abyss, we should not only ask what we see, but what we might be missing. For in the silence of gravastars, in their hollow hearts and fragile shells, may lie the ultimate revelation, that the universe is not a simple stage, but a masquerade. And every mask it wears is an invitation to wonder, to fear, and to step closer to the truth hidden just beyond the curtain. The more deeply we study the universe, the more it feels like a vast puzzle with missing pieces. For every discovery, a new riddle emerges. Dark matter, dark energy, the accelerating cosmos. Each one reshapes our understanding, but none of them completes the picture. Gravastars may be yet another piece, one that doesn't simply fit into the puzzle, but changes the puzzle itself. They are not just astrophysical curiosities. They could be signs that the universe is more layered, more multidimensional than we ever dared imagine. At the heart of gravastars lies vacuum energy, the same enigmatic force responsible for the universe's expansion. This link is not trivial. If gravastars exist, they are not isolated oddities. They are woven into the very fabric of cosmic destiny. Their hollow centers may be miniature versions of the universe itself, tiny bubbles of expansion trapped within shells of matter. To study them is to study the same phenomenon that shapes the grandest structures of all. Gravastars become microcosms of the cosmos, fractal echoes of the universe repeating at different scales. This leads to a radical possibility. Could gravastars be portals to other universes? If the vacuum inside their shells is unstable, it might trigger what physicists call false vacuum decay, the collapse of one state of spacetime into another. In theory, such a collapse could create a new universe, expanding from the seed hidden inside the gravastar, disconnected from our own. From our perspective, the object might vanish in a burst of energy. From the inside, an entirely new cosmos would be born. In this way, gravastars might be not only masks of black holes, but cradles of multiverses, scattered across reality like hidden seeds. If true, then every gravastar is both an ending and a beginning. The death of one star could be the birth of an entire universe, invisible to us but vast to those within it. Suddenly, the idea of a multiverse stops being philosophical speculation and becomes astrophysical consequence. Gravastars may not simply live in our universe, they may carry universes inside them. This concept forces us to confront the meaning of endings. For centuries, humans imagined the universe would have one fate: eternal stasis, fiery collapse, or cold death. Modern cosmology has debated scenarios like the Big Freeze, the Big Rip, and the heat death of the cosmos. But gravastars complicate this narrative. If they are capable of spawning new universes, then our own cosmos may be just one link in an endless chain of creations. Endings are no longer final. They are transitions, doorways through which the fabric of reality continually renews itself. And here lies the terrifying beauty. If gravastars can create universes, then perhaps we ourselves live inside one. Our own Big Bang may have been the rupture of a gravistar in a larger cosmos, an explosion of vacuum energy seeding a new reality. In that case, gravastars are not distant curiosities. They are our ancestors. Every galaxy, every star, every human life may trace its origin not to a singularity, but to the hollow heart of a gravistar from a universe before ours. This perspective transforms gravastars into cosmic storytellers. They are the keepers of continuity, the mechanism by which existence refuses to end. When one universe collapses, another begins. When one star dies, a cosmos awakens. And in this cycle lies a new way of understanding time itself. Time is not a line from beginning to end, but a web of rebirths, each gravistar a knot tying one universe to the next. Yet for all their grandeur, gravastars remain invisible in our skies. If they exist, they are indistinguishable from black holes with our current instruments. This raises a philosophical paradox. Reality may be filled with gateways, but we cannot recognize them. We live surrounded by mysteries wearing masks. We build stories of certainty, but the truth is hidden in plain sight. Gravastars remind us that ignorance is not a failure of knowledge. It is a property of the cosmos itself. For civilizations capable of detecting them, gravastars may represent both peril and opportunity. A nearby gravistar might threaten with catastrophic instability, but it might also tempt explorers with the possibility of tapping vacuum energy or even crossing into new universes. To contemplate such ventures is to blend science with mythology, to imagine starships sailing not through space, but through space-time itself, seeking passage into the unborn realities waiting inside. And what of the end of our own universe? If expansion continues unchecked, stars will fade, galaxies will grow cold, and entropy will reign. Yet gravastars, if they exist, may be the last actors left on this stage. While black holes evaporate over unimaginable timescales, gravastars may persist, hollow bubbles of vacuum energy humming in the dark. Their ruptures could seed new beginnings, continuing the chain of universes long after ours is forgotten. In that sense, gravastars may be the vessels of eternity, carrying creation forward into infinities beyond imagination. It is humbling to think that such objects might exist right now, in the galaxies we admire through telescopes, masquerading as black holes. Perhaps when we peer into the heart of the Milky Way, into Sagittarius A-, we are not looking at a singularity but at a gravistar. Perhaps our galaxy itself is balanced on the edge of such a hollow mystery. We do not know, but the possibility changes everything. And maybe that is the real gift of gravastars. They force us to see that the universe is not finished, not settled, not fully explained. Every discovery reveals another mask, another disguise, another question mark painted across the sky. Gravastars may be the strangest of all these masks, but they carry a simple lesson. Reality is larger than certainty, and truth is stranger than fear. If they exist, gravastars are not just astrophysical objects. They are symbols of cosmic continuity, engines of rebirth, whispers of universes hidden inside the shadows of our own. They are terrifying not because they destroy, but because they reveal that destruction itself may be an illusion. Behind every ending lies a beginning. Behind every mask lies another face. And behind the silence of gravastars may lie the loudest truth of all, that existence never ends, it only transforms. The universe speaks in many languages. Sometimes it speaks in light, the glow of stars, the shimmer of nebulae, the faint afterglow of the Big Bang itself. Sometimes it speaks in particles, cosmic rays streaking through space, neutrinos whispering through matter. And sometimes the cosmos speaks in vibrations of spacetime itself. These are gravitational waves, ripples born of cosmic collisions, carrying with them the unedited signatures of the most violent events the universe can stage. When LIGO first detected gravitational waves in 2015, humanity entered a new era. For the first time, we could listen to the universe, not just watch it. The merger of black holes sounded like a distant thud, a faint cosmic drumbeat reverberating across 1 billion years. Since then, dozens of such detections have confirmed what Einstein predicted. that space-time is elastic, that massive objects can bend it, twist it, and send ripples across it like stones cast into a pond. But hidden in those ripples may be secrets we have not yet deciphered. Because if gravastars exist, their collisions would not sound the same as black holes. Black holes merge and then fall silent, their ring down neat and final. Gravastars, with their hollow cores and dense shells, might reverberate differently. Instead of fading smoothly, they could produce echoes, faint repetitions in the gravitational wave signal, like a cosmic heartbeat refusing to die. These echoes are more than noise. They are potential evidence that what we thought were black holes may be something else entirely. Already, researchers are combing through the data, hunting for patterns, anomalies, irregularities that defy the expected. A single confirmed echo could upend astrophysics, forcing us to confront the reality that some of the black holes cataloged in our universe are imposters. Gravastars, masquerading perfectly until the moment of collision, would finally reveal themselves through the music of space-time. Future missions will sharpen this listening. The planned laser interferometer space antenna LISA will drift in orbit around the Sun, stretching millions of kilometers in scale, tuned to catch lower frequency waves from supermassive objects. If gravastars exist at the centers of galaxies, then their mergers may one day be recorded in exquisite detail, carrying with them the long-awaited echoes of hollow hearts collapsing and colliding. For the first time, humanity could have proof that the universe wears masks, that not every shadow we call a black hole is what it seems. The scientific consequences would be enormous. Entire models of stellar death and galactic evolution would need revision. Our simulations of cosmic structure would shift. Textbooks would be rewritten. But the cultural consequences may be even greater, because gravastars would remind us that certainty is temporary, that even the most settled science can give way to stranger truths. The public imagination would be captured not just by the objects themselves, but by the idea that the universe is full of disguises, and that we have only begun to peel them away. Consider how black holes already transformed culture. Once exotic abstractions, they became icons of science fiction, metaphors for death, time, and infinity. They appeared in novels, films, art, and philosophy, shaping how humanity thinks about the abyss. Gravastars, if discovered, would take this even further. They would not simply symbolize death, they would symbolize ambiguity. They would become metaphors for uncertainty itself, for masks, for hidden realities behind appearances. In literature and art, they could embody the tension between what is seen and what is true. In philosophy, they could challenge our concepts of finality, forcing us to ask whether any ending is ever absolute. And in science, gravastars would become more than objects. They would be laboratories of extremes, offering us a glimpse into the interplay between general relativity and quantum mechanics, the two great pillars of physics that so often resist unification. Inside their hollow shells may lie clues to the theory of everything, a framework that reconciles the cosmic with the quantum. In chasing gravastars, we are not just chasing astrophysical anomalies. We are chasing the deepest harmony of nature itself. Yet there is something humbling in this chase, because to prove gravastars exist, we must stretch our instruments and our imaginations to their limits. We must listen for faint echoes across cosmic distances, parse out signals from the noise of the universe, and risk the possibility that the evidence will remain forever ambiguous. Gravastars may taunt us, hiding behind the perfect mimicry of black holes, revealing themselves only in whispers too faint for us to hear. But even this ambiguity is valuable, for it teaches us that science is not about certainty, but about pursuit. It is about daring to imagine alternatives, daring to question assumptions, daring to ask whether the monsters we fear are truly what they seem. Gravastars are as much a lesson in humility as they are a potential discovery. They remind us that knowledge is not static, but dynamic, a conversation between what we see, what we think, and what may lie beyond. And perhaps this is why the idea of gravastars resonates so deeply. They are not simply astrophysical curiosities. They are metaphors for the human condition. We too wear masks. We too carry hollow spaces inside us, filled not with certainty but with questions. We too stand at the edge of the unknown, pretending we understand more than we truly do. Gravastars mirror us, in their ambiguity, in their danger, in their potential for hidden depth. So, when the next gravitational wave ripples through the Earth, recorded by detectors straining to hear the faintest tremors of spacetime, we may ask, was that the death cry of black holes? Or was it the echo of something stranger, something hollow, fragile, and filled with the power of the vacuum itself? Perhaps, in those echoes, we will hear the universe confess its disguise. Perhaps we will finally know that the cosmos has been hiding gravastars in plain sight all along. And when that day comes, humanity will not only have discovered a new kind of object, we will have discovered, once again, that the universe is bigger, stranger, and more mysterious than our imagination ever allowed. Gravastars will join the pantheon of discoveries that humbled us, from the heliocentric model to relativity to quantum mechanics. They will remind us that wonder and fear are not opposites, but companions, that to listen is as important as to see, and that sometimes the universe speaks not in light, but in echoes. What would it mean for us, here on this small planet, to discover that gravastars are real? To realize that the black holes we've charted across the cosmos may not be what they seem, but imposters with hollow hearts. The answer reaches far beyond astronomy. It touches the very way we see ourselves. Humanity has always lived with shadows overhead. For ancient peoples, comets and eclipses brought terror, portents of doom. Later, science replaced fear with understanding. We learned the stars are suns, the Earth a planet among billions, the Milky Way one galaxy among trillions. Yet every discovery, while expanding our knowledge, also shrank our sense of importance. Black holes were among the most humbling revelations. Vast, unstoppable, indifferent to life. They taught us that the universe is not built for us. But gravastars would push that humility even further, because they would reveal not only that the universe is stranger than we imagined, but that it wears disguises. That even when we think we understand, we may only be staring at masks. Gravastars would strip away the illusion of certainty, leaving us face to face with the fact that reality is layered, ambiguous, and full of secrets too deep for our current science to grasp. This revelation would challenge culture as much as physics. Imagine the impact on philosophy, on religion, on art. Gravastars would become metaphors for hidden truth, for the hollowness inside what seems solid, for the idea that even the most terrifying monsters might not be what they appear. Writers would seize the image of the hollow star as a symbol of ambiguity. Philosophers would debate whether gravastars prove that the universe avoids infinity, or whether they are simply reminders of our ignorance. Religions might see them as cosmic signs, not of finality, but of hidden creation. But perhaps the greatest impact would be psychological. For gravastars embody unpredictability. Black holes, as deadly as they are, follow rules we understand. They attract, they consume, they evaporate slowly. Gravastars are different. They may collapse, reflect, or explode. Their shells might rupture after billions of years or tomorrow. For civilizations living near them, this uncertainty would breed unease. To live beneath a gravastar would be to live with an invisible fault line in the sky, never knowing if stability or catastrophe lies ahead. Humanity, upon discovering them, would inherit that same unease, a new reminder of our fragility in a cosmos not designed for comfort. And yet, there would be wonder too, because gravastars are not only threats, they are opportunities. They may hold the key to understanding dark energy, the most profound mystery of our time. To probe a gravistar would be to probe the very force accelerating the universe's expansion. They would become natural laboratories, windows into physics that could one day reshape technology, energy, even survival itself. The same hollowness that terrifies could also enlighten, if only we can learn to study it. Civilizations thrive on stories, and gravastars would change ours. They would remind us that endings are not always what they seem, that destruction can conceal creation, that silence can hide echoes. For a species that has always sought meaning in the stars, gravastars would offer new metaphors: the mask, the hollow, the portal, They would teach us to embrace uncertainty, to see mystery not as a threat but as a companion. But they would also force us to confront vulnerability. Imagine the public reaction if astronomers announced that one of the supposed black holes near the Milky Way might actually be a gravastar, a shell that could one day rupture. The headlines would shout doomsday. The reality, of course, is that such events are rare on human timescales. But the psychological weight would remain. We would know that our galaxy houses not only predictable monsters but unpredictable enigmas. And in that awareness, we would see ourselves more clearly. Fragile, transient, but also endlessly curious. The irony is that gravastars, for all their menace, might inspire humanity to grow, because they remind us that survival requires not only knowledge, but imagination. If we are to face a universe of masks and mysteries, we must be bold enough to question, to explore, to seek beyond appearances. Gravastars could ignite a new age of science, driving us to build instruments capable of peeling away the disguises of reality, to listen for echoes in spacetime, to measure the subtlest flickers of light. And in doing so, they could inspire generations to pursue knowledge not as comfort, but as courage. Perhaps that is their true gift. Gravastars do not simply challenge our physics. They challenge our confidence. They remind us that we are small, that certainty is fragile, and that the cosmos is full of surprises. But in the same breath, they remind us that our strength lies in curiosity, in the ability to ask, to wonder, to imagine. The hollow shells in the sky may frighten us, but they also invite us to step closer, to peel away the mask, to seek the truth hidden within. And so, gravastars become not only objects of astrophysics, but symbols of humanity's journey. They are reminders that we live beneath a hollow sky, where even the most terrifying shadows may contain hidden meanings. They are metaphors for our own existence, fragile shells, filled not with certainty, but with questions. And if we can embrace those questions, if we can find wonder even in the masks, then perhaps gravastars will not only change our science, but transform the way we see ourselves. Because in the end, gravastars are not only about the universe. They are about us, about our fear of the unknown, our hunger for truth, and our ability to find beauty in the hollowness of mystery. When humanity first looked up at the stars, we saw stories. Constellations became hunters and lions, gods and lovers, myths written in the night sky. Those stories gave us identity. They told us who we were, where we belonged, and how to navigate the uncertain seas of existence. Today, the sky tells us a different story, one written not in myth but in physics. But it still defines us. It still shapes our identity as a species. And gravastars may be the next chapter in that evolving story. We are, after all, creatures of context. To know ourselves, we look outward. The discovery that Earth is a planet reshaped our philosophy. The realization that the Milky Way is only one galaxy among trillions redefined our scale. The detection of black holes forced us to confront the power of gravity and the fragility of life. Each revelation in astronomy has been more than scientific. It has been cultural, existential. Gravastars, if proven real, would join this lineage. They would not simply change equations. They would change the mirror in which humanity sees itself. What would that mirror show? First, it would reveal that the universe is not only stranger than we thought, but trickier. Black holes already humbled us, but gravastars would humiliate our assumptions even further. They would prove that the cosmos wears disguises, that even with the best instruments and theories, we can mistake one monster for another. This realization would cut deep into the story of human progress. For centuries, we have imagined science as a gradual march toward certainty. Gravastars would remind us that certainty itself may be an illusion, that knowledge is not a destination but a shifting frontier. And yet, in that humility lies empowerment. To accept that gravastars exist is to accept that the universe is not finished revealing itself. It is to admit that our story as a species is far from complete. We are apprentices of the cosmos, still learning its language, still deciphering its masks. This realization could shape a new identity for humanity, not as masters of knowledge, but as explorers of endless mystery. For a future interstellar civilization, this identity may be essential. To survive among the stars, we must carry not just technology, but philosophy. We must carry the resilience to live with uncertainty. Imagine starships journeying into the deep, guided by maps of black holes, and then discovering that some of those black holes are gravastars. Entire strategies of navigation, energy harvesting, and survival would need rethinking. The discovery of gravastars would not just alter our science. It would alter the very way we plan our cosmic future. And here lies a subtle irony. Gravastars, for all their hollowness, could fill us with a new sense of purpose. Because they embody the unknown, they remind us that exploration is never complete. Every star system could hold surprises. Every shadow could conceal ambiguity. For a species poised to step beyond its homeworld, this awareness is vital. It guards us against arrogance, prepares us for wonder. It teaches us that the universe is not a solved puzzle, but a living enigma. But gravastars also raise unsettling questions about survival. If these objects can destabilize, erupt, or collapse into bursts of unimaginable energy, then they represent risks on a galactic scale. Civilizations living near them may face sudden annihilation. For humanity, the awareness of such threats would reshape our understanding of cosmic security. Just as early sailors learned to respect storms, interstellar civilizations must learn to respect gravastars, to chart them, to study them, to treat them not only as curiosities but as hazards. Yet danger and opportunity often walk hand in hand. Gravastars might one day be seen not only as risks but as resources. Their vacuum energy, if harnessed, could power civilizations for millennia. Advanced societies might build stations orbiting them, drawing energy from their strange interiors. To us, this sounds like science fiction, but so did flight, electricity, and space travel once. Gravastars may someday become the engines of interstellar culture, symbols not of fear, but of resilience, adaptation, and ingenuity. Their cultural symbolism would be profound. Black holes have already become icons of death, silence, and finality. Gravastars would add nuance. They would symbolize ambiguity, hidden truths, and the coexistence of destruction and creation. Artists would paint them as hollow masks in the sky. Writers would use them as metaphors for identity itself, the fragile shell, the hidden void, the power of what lies unseen. Children would grow up with gravastars in their textbooks, learning not only about physics but about humility. And in this cultural shift, humanity's cosmic identity would evolve. We would no longer see ourselves as small creatures lost in an indifferent universe. Instead, we would see ourselves as participants in a grand dialogue with mystery. The discovery of gravastars would not diminish us. It would challenge us to rise, to embrace complexity, to live not with answers but with questions. It would forge an identity built on curiosity, resilience, and wonder. Perhaps this is why the idea of gravastars feels so resonant, even before they are proven real. They remind us of ourselves. We too wear masks. We too have hollow spaces filled with uncertainty. We too contain contradictions, fragility and strength, fear and courage, destruction and creation. Gravastars mirror humanity not as we wish to be, but as we are, complex, uncertain, and endlessly searching for meaning. In the end, gravastars may never be confirmed. They may remain speculation, shadows of mathematics that reality never paints. But even then, their value endures, because they have already expanded our imagination. They have already reshaped how we think about the universe, and therefore how we think about ourselves. Gravastars may or may not exist in the heavens, but they now exist in us, in our stories, our metaphors, our search for truth. And perhaps that is the greatest transformation of all. For a species that began by telling myths about constellations, to now tell myths about gravastars, not gods but physics, not fantasies but possibilities, is itself a triumph. It shows that our cosmic identity is not fixed, but evolving, that we are capable of weaving new stories as the universe reveals new masks, and that, in the face of the hollow stars, we are ready not only to fear, but to imagine, to wonder, and to seek. Because in the hollow heart of a gravistar lies not just dark energy, it lies the reminder that identity itself is a journey. For the cosmos, for humanity, for every mind that dares to look up at the night sky and ask, what if? Time has always been our most intimate companion and our most relentless enemy. We measure our lives in hours, our histories in centuries, and the cosmos in billions of years. Time gives rhythm to existence, but it also gives us endings. Stars fade, galaxies drift apart. Even the universe itself seems bound to a final fate. Yet gravastars, if they exist, might change how we think about time and about the fragile boundary between reality and perception. Black holes already bend time into shapes we can scarcely imagine. Near their horizons, clocks slow. To fall toward one is to enter a world where seconds stretch into eternities, where what is now for you might be never for the rest of the universe. Gravastars, with their hollow interiors of vacuum energy, push this distortion further. Their shells compress space-time with gravity, while their cores expand it with dark energy. They are arenas where two competing visions of time collide. For a human mind, to approach such an object would be to enter a paradox. Gravity pulling you into timelessness, expansion stretching you into acceleration. This paradox is not just physics, it is philosophy. It asks whether time is absolute or whether it is only an emergent property of deeper processes. Gravastars, in their very structure, suggest that time can fracture, that one region of the cosmos may dilate while another accelerates, that what we call the flow of time is neither universal nor singular. And in contemplating this, we glimpse a truth about ourselves, that our consciousness, too, is bound by perception, by limited frames, by masks we mistake for absolutes. The idea is unsettling, because if gravastars are real, then the end of time itself may not be what we imagine. Cosmologists speak of heat death, of entropy spreading evenly until the universe is a silent sea of cold. They speak of the Big Rip, where expansion tears apart galaxies, stars, and even atoms. They speak of collapse, of the universe folding back in on itself. But gravastars complicate this story. They hint that within pockets of space-time, endings may not mean silence. They may mean transformation. A ruptured gravastar might seed a new timeline, a new rhythm of existence, a continuation of time hidden inside an apparent finale. This forces us to question the very nature of finality. Perhaps the universe never truly ends. Perhaps what we call endings are only transitions, masks that time itself wears, disguising rebirths as conclusions. Gravastars, with their hollow hearts, embody this ambiguity. They are neither stars nor black holes, neither creation nor destruction. They are thresholds, and thresholds are never endings. They are beginnings in disguise. For humanity, this revelation would be profound. We live with the fear of endings, of personal death, of cultural collapse, of cosmic silence. Our myths, our religions, our philosophies are filled with stories that wrestle with finality. To discover that gravastars may carry within them the seeds of new time would not erase that fear, but it would transform it. It would show us that what looks like an abyss may conceal continuity, that silence may echo, that time itself may refuse to die. And in this sense, gravastars resonate with consciousness. For our minds, too, are bounded by masks. Neuroscience tells us that perception is not reality, but an interpretation. Our brains construct the world from fragments, filling in gaps, disguising complexity with simplicity. We believe in continuity because our minds stitch it together. Gravastars remind us that the cosmos may do the same, stitching endings into beginnings, disguising transitions as permanence. In them, we see not just astrophysics, but a mirror of thought itself. This mirroring invites a bold question. Could gravastars become more than subjects of study? Could they become metaphors for how we understand reality at its deepest level? Perhaps they are not just cosmic objects, but cosmic lessons, teaching us that the universe itself wears masks of perception, that what seems final may be hollow, and that the true structure of existence lies beneath appearances. Imagine the cultural shift if this idea took hold. Artists might paint gravastars as gateways of time, their shells glowing like curtains between epochs. Poets might describe them as pauses in eternity, silences that give rise to new songs. Philosophers might argue that gravastars prove reality is layered, that endings and beginnings are illusions of scale. Even ordinary people, looking at the night sky, might feel not despair at its darkness, but awe at its hidden continuities. For a future civilization, gravastars could redefine the meaning of survival. If inside them lies the possibility of rebirth, then perhaps existence itself is indestructible. Perhaps civilizations are never truly erased, but echoed in new universes, new timelines, seeded by ruptures we cannot yet fathom. This is speculation, of course, but speculation is the beginning of every revolution in thought. Gravastars dare us to speculate, to imagine, to question not only physics but destiny. And so, gravastars link the cosmic with the personal. They remind us that our fear of endings may itself be a mask, that consciousness, like time, may not cease but transform, that even the collapse of stars may conceal a rhythm continuing in secret. They tell us that the universe is not a straight line to silence, but a labyrinth of thresholds, each hollow shell leading to something new. In their darkness, gravastars carry light. In their hollowness, they carry fullness. In their silence, they carry echoes. They are not just terrifying possibilities in astrophysics. They are invitations to reconsider reality itself. And if we accept that invitation, we may find that time does not end, that consciousness does not vanish, that endings are illusions, and that the hollow stars are teaching us the deepest lesson of all, that existence never stops becoming. Science thrives on anomalies. Every great leap in understanding has begun with something that didn't fit. A wobble in a planet's orbit, a faint glow in the night sky, a particle that arrived where it wasn't expected. Gravastars may one day join this tradition. They are not merely theoretical curiosities. They are potential signposts pointing us toward the next frontier of physics. If black holes taught us the power of Einstein's relativity, then gravastars may teach us the path to whatever comes beyond it. For a century, physics has rested uneasily on two pillars: general relativity, the theory of the very large, and quantum mechanics, the theory of the very small. Both have been tested to extraordinary precision. Both have reshaped our understanding of the cosmos. And yet, they refuse to speak the same language. At the heart of a black hole, the singularity, this clash becomes unavoidable. Relativity predicts infinite density. Quantum mechanics insists infinities cannot exist. Gravastars emerge in this space of contradiction, offering a possible resolution. By replacing singularities with shells and hollow cores, they eliminate the infinities that mathematics cannot tolerate. They whisper of a bridge between the two great theories, a glimpse of the long-sought quantum gravity. If gravastars are real, then they are not only astrophysical objects but laboratories of the unification problem. Their very existence would tell us that the universe has a natural mechanism to avoid infinities, that physics contains built-in corrections we have not yet seen. Studying them would mean probing the seam where relativity and quantum theory finally meet. That seam could redefine not just astrophysics but the entire foundation of science. But to reach that seam, we need new tools. The telescopes we have today, Hubble, James Webb, the Event Horizon Telescope, have already shown us marvels, from the faintest galaxies to the shadows of supermassive black holes. Yet gravastars demand more. We need instruments capable of detecting the tiniest deviations in light curves, the faintest echoes in gravitational waves, the most delicate fluctuations in spacetime itself. This is the promise of tomorrow's observatories. The implications extend further still. If gravastars truly hold dark energy within their cores, then studying them may reveal clues to one of the greatest mysteries of all: why the universe accelerates. Dark energy has been measured on cosmic scales, but never in local laboratories. Gravastars would change that. They would be natural containers of the same force driving cosmic expansion. To analyze them is to analyze the engine of the universe itself. A future science capable of measuring their interiors might finally tell us what dark energy really is, whether it is a constant of nature, a dynamic field, or something even stranger. Such a discovery would ripple across disciplines. Cosmology would gain a new foundation. Particle physics might uncover new fields and symmetries. Even mathematics would be reshaped as infinities yield to new structures of spacetime. gravastars, once only speculation, could become the Rosetta Stone of modern physics, the key that deciphers the language connecting the very large with the very small. And yet, their study would not only challenge our theories, it would challenge our imagination. For centuries, science has advanced not by comfort but by courage. The courage to imagine that Earth orbits the sun, that matter is atomic, that time itself bends. Gravastars demand the same courage. They ask us to believe that the universe wears disguises, that black holes may be imposters, that hollow shells of energy may lurk behind the shadows we thought we understood. To confront them is to accept that the universe is cleverer than us, and that its cleverness is an invitation, not a threat. If confirmed, gravastars would become a milestone comparable to Galileo's telescope or Einstein's equations. They would show that even in the 21st century, the cosmos is still capable of shocking us, of forcing us to rewrite our deepest assumptions. And this, perhaps, is their greatest promise. For a species that longs to explore, nothing is more vital than the reminder that there are still mysteries left to chase. In the end, gravastars are not just about the physics of collapsed stars. They are about the future of science itself. They are a call to build bigger instruments, to think bolder thoughts, to push beyond the horizon of current knowledge. They are the next questions waiting beyond our answers, the next puzzles waiting beyond our solutions. And if we dare to pursue them, we may find that in their hollow silence lies the bridge we have sought for a century. The bridge between relativity and quantum mechanics, between the known and the unknown, between certainty and wonder, because that is what science is at its core. The courage to listen when the universe whispers, and the humility to realize that the whispers are often stranger than our dreams. Gravastars are that whisper now. The future of physics may depend on whether we choose to hear it. Human beings have always built their identities around stories. Long before telescopes, before mathematics, before physics, we looked up at the night sky and filled it with meaning. Orion was a hunter, Perseus a hero, the Milky Way a river of souls. Stars were not just lights. They were mirrors for our imagination. Every discovery we have made since, from Galileo's moons of Jupiter to Hubble's expanding universe, has not erased those stories but transformed them. Science itself has become a form of mythology, a way to explain the unknown, a language of awe. If gravastars are real, they will write the next chapter in that mythology. Because they are not merely scientific hypotheses, they are archetypes. They embody the universal themes of disguise, ambiguity, death, and rebirth. They are cosmic symbols as much as astrophysical objects. And like black holes before them, they will seep into culture, art, and the collective imagination of humanity. Imagine the paintings of the future. Canvases filled not only with spirals of galaxies, but with dark spheres encased in glowing shells, masks of light surrounding hollows of silence. Sculptors might carve forms where emptiness is the center, the void itself becoming the subject. Filmmakers could weave stories where gravastars are metaphors for hidden truths, for civilizations living beside dangers they cannot name, for thresholds to other worlds disguised as endings. Just as the black hole became the cinematic emblem of mystery and terror, the gravastar could become the artistic emblem of ambiguity, the reminder that not everything is what it seems. Literature, too, would embrace them. Poets might write of hollow suns, of stars that pretend to die but hide seeds of rebirth. Novelists could use gravastars as backdrops for human struggles, metaphors for identity and deception, mirrors for the masks we wear. They could become the symbols of a new existentialism, not the despair of nothingness, but the tension of uncertainty. A gravastar is never final. It is suspended between possibilities. And so, it echoes the human condition itself, fragile, uncertain, searching for meaning. Philosophy would also change. Gravastars would challenge our concepts of reality. They would ask whether existence is ever truly solid, or whether all we know is layers of appearances. They would blur the line between science and metaphor, forcing us to admit that even in physics, symbols matter. To say gravastar would be to speak not only of equations but of archetypes, the mask, the hollow, the portal. They would become the platonic forms of modern science, objects both real and symbolic, straddling the worlds of mathematics and meaning. Religion, too, might find echoes in them. Traditions across the world have spoken of hidden worlds, of creation arising from emptiness, of death that conceals rebirth. Gravastars, with their hollow centers of vacuum energy, would resonate with these myths. They could be seen as cosmic metaphors for resurrection, for the void that gives rise to being. In this way, gravastars would not only transform science but also intertwine with the deepest narratives of humanity's spiritual heritage. And then there is the mythology of the future, the myths we have not yet written. As humanity becomes a spacefaring civilization, our stories will no longer be bound to Earth. We will need new epics, new symbols to guide us across the stars. Gravastars may become part of that cosmic folklore. Pilots of interstellar craft might speak of the hollow suns as omens or guides. Colonies orbiting distant worlds may build legends around nearby gravastars, telling children stories of thresholds in the sky, of monsters that are not what they seem. Science will identify them, measure them, model them, but culture will weave them into myths because that is what humans do. We transform knowledge into meaning. And meaning, ultimately, is what gravastars will give us. They are terrifying because they unsettle certainty, but they are inspiring for the same reason. They remind us that the universe is not a closed book, that even the most terrifying shadows may hide mysteries beyond comprehension. They challenge us to live not with answers but with questions, not with finality but with ambiguity. And that challenge will echo in every domain of human expression: science, art, philosophy, and myth. The greatest myths are not about gods or heroes. They are about the unknown. The dragon at the edge of the map, the abyss beyond the horizon, the void in the heart of the cosmos. Gravastars are the modern dragon, the abyss disguised as something familiar. They are the new myth for a species standing on the threshold of interstellar life. They tell us that danger and wonder are the same thing, that the masks of the universe are never fully lifted, and that our role is not to conquer the unknown but to continue the story. So perhaps, centuries from now, when our descendants sail between the stars, gravastars will no longer be abstract. They will be destinations, landmarks, dangers, and inspirations. And just as ancient sailors once told stories of sea monsters, interstellar travelers may tell stories of hollow stars, of the masks the cosmos wears, of the echoes hidden in space-time. Those stories will guide them as surely as constellations once guided us. And when they do, gravastars will have fulfilled their greatest role, not just as scientific discoveries, but as myths reborn. They will remind us that to be human is not only to know but to imagine, not only to survive but to create meaning. The hollow stars will live in our science, yes, but also in our art, our poetry, our philosophy, and our dreams. Because in the end, gravastars are more than objects. They are symbols of the endless dialogue between knowledge and mystery. They are the new myths of a hollow universe, teaching us that emptiness itself can be full of wonder. History shows us that knowledge reshapes power. The invention of the compass redrew maps. The discovery of electricity transformed economies. The splitting of the atom reshaped geopolitics, creating both terror and opportunity. Now imagine a discovery as radical as gravastars, objects that mimic black holes yet conceal vacuum energy within. The impact would reach far beyond astronomy. It would ripple into politics, into technology, into the very strategies humanity adopts to survive. The first consequence would be existential awareness. For centuries, black holes have represented distant threats, awe-inspiring but remote. Gravastars would change that calculus. They introduce unpredictability into the night sky. Unlike black holes, which obey rules we've come to accept, gravastars could destabilize, erupt, or rupture without warning. If astronomers were to identify even one within our galactic neighborhood, governments and populations would feel the weight of cosmic vulnerability. The politics of fear would no longer be confined to Earth. We would be living not just under the shadow of nuclear arsenals or climate change, but under the possibility that the sky itself harbors disguised catastrophes. But fear alone does not define human history. Opportunity does. Gravastars, if real, could also become the most valuable natural resources in the universe. Inside their hollow hearts lies vacuum energy, the very force accelerating cosmic expansion. If harnessed, even partially, this energy could dwarf anything humanity has ever known. Entire civilizations could be powered by a single gravastar, their cities and starships fueled by the pressure of the void itself. The race to study, contain, or exploit this energy would inevitably ignite competition among nations, corporations, and eventually interstellar colonies. Gravastars would become the oil fields of the cosmos, contested and coveted, guarded as both treasures and weapons. And here lies the danger: weaponization. If a gravastar could be destabilized intentionally, the release of its energy could become the most devastating weapon in history. Far beyond nuclear arms, beyond antimatter, beyond anything we can currently conceive. The possibility would drive new treaties, new rivalries, new forms of deterrence. The politics of gravastars would be the politics of survival at an unprecedented scale. Yet not all outcomes need be dark. Gravastars could also drive cooperation. Just as the International Space Station symbolized a fragile unity amid Cold War rivalries, the study of gravastars might force nations to collaborate. No single nation could hope to explore them alone. The instruments required, the distances involved, the risks to manage, these would demand alliances, treaties, and shared effort. Humanity might, for the first time, see itself not as fragmented states but as a single species facing a cosmic challenge. Gravastars could become the catalysts for planetary unity. On the technological front, their discovery would revolutionize science. Telescopes and detectors would multiply, governments pouring resources into missions to probe these hollow stars. Robotics would be dispatched to orbit them, measuring their emissions, mapping their shells. Advances in propulsion, energy collection, and space-time modeling would follow. Entire industries could emerge around gravastar science, just as aviation and computing grew from earlier scientific revolutions. The technologies born from this pursuit might spill into daily life. New forms of energy storage, new medical imaging derived from gravitational research, new materials forged from experiments in extreme conditions. And what of philosophy, of culture? Gravastars would reshape the way humanity tells its own story. Politicians might invoke them as symbols of resilience or caution. Movements might arise calling for the ethical use of gravastar energy, echoing today's debates about climate and sustainability. Artists could interpret them as metaphors for power concealed in silence, for danger wrapped in beauty. In classrooms, children would learn that the universe itself wears masks, and that survival depends not only on science but on wisdom. The very idea of survival strategy would change. Until now, humanity has imagined threats from within: wars, pandemics, resource scarcity. Gravastars would add an external threat, not hostile by intent, but dangerous by nature. They would remind us that the universe itself can threaten civilizations, not with malice but with physics. To prepare for such dangers, humanity would need to develop long-term resilience. Interplanetary colonies, diversified habitats, technologies capable of shielding worlds from bursts of radiation or gravitational upheaval. Gravastars would push us to think not in centuries, but in cosmic timescales. This shift could mature our species. For too long, we have acted as if Earth is the entire stage, as if politics begins and ends with our borders. Gravastars would shatter that illusion. They would force us to realize that survival requires cosmic perspective, that politics must expand beyond nations to civilizations, beyond centuries to millennia, beyond Earth to the stars. The discovery of gravastars could be the very catalyst that transforms humanity from a planetary species into a cosmic one. And perhaps that is their hidden role. Gravastars are not only hollow stars. They are hollow mirrors, reflecting back to us our fragility and our potential. They show us that power and danger are intertwined, that survival requires imagination, and that the greatest resources come not from what is obvious, but from what is hidden. They remind us that history is not confined to Earth. It is written in the stars as well. In the end, gravastars would not only alter science. They would alter civilization. They would change how we build, how we govern, how we dream. They would become symbols of both peril and possibility. Reminders that the cosmos does not merely surround us, it shapes us. And as we stand beneath that hollow sky, we would realize that our destiny is not just to fear gravastars, nor to exploit them, but to learn from them, to see in their hollow hearts a reflection of our own journey, fragile, uncertain, but capable of becoming something greater. For as long as we have looked at the stars, we have seen beauty in them. The twinkling lights of the night sky, the colors of nebulae, the slow dance of planets, all have stirred us not only as scientists, but as poets, painters, dreamers. The cosmos has always been a canvas, and humanity has always been its interpreter. Yet with gravastars, the concept of beauty itself may change, because these objects embody a paradox. The aesthetic of emptiness, the elegance of ambiguity, the allure of the unseen. At first glance, there is nothing beautiful about them. To an astronomer's eye, a gravastar looks like a black hole, a dark silhouette against the brightness of an accretion disk, a shadow framed by starlight. But beauty is not only what is visible. Beauty lies also in what is suggested, in what is hidden, in the mysteries that beckon us closer. Gravastars carry this allure in abundance. Their very hollowness becomes an artistic statement that what we cannot see may be as powerful, as profound, as what we can. Art thrives on tension, and gravastars embody it. They are shells surrounding nothingness, forms that pretend to be final yet contain potential. Painters of the future might depict them as glowing rings around perfect voids, symbols of fragile containment. Musicians might compose pieces inspired by their imagined echoes, reverberations of space-time that resonate like notes held too long. Poets might write of hollow suns that hold universes in silence. Gravastars, once understood, will not remain confined to equations. They will spill into imagination, reshaping the way beauty itself is defined. In this sense, gravastars extend an older tradition, the sublime. Philosophers once distinguished between the beautiful and the sublime. Beauty was harmony, symmetry, proportion. The sublime was terror mixed with awe, the grandeur of mountains, storms, and the infinite. Black holes already embody the sublime. Infinite gravity, infinite silence, infinite fear. Gravastars take this further. They are not only sublime in power, but sublime in ambiguity. They terrify us not just with destruction, but with uncertainty. Their beauty is the beauty of masks, of riddles, of faces that do not reveal themselves. For humanity, this aesthetic shift may be transformative. Imagine standing beneath a night sky where gravastars are known. You would not only see stars, you would see disguises. Every dark silhouette could be something other than it seems. The cosmos itself would appear as a gallery of illusions. This awareness would heighten the beauty of the universe, not diminish it. Because beauty thrives in complexity, in depth, in the interplay between known and unknown. Gravastars would remind us that the universe is not a flat picture but a layered tapestry, full of secrets waiting to be felt as much as measured. Even science itself would gain a new aesthetic. Physicists already speak of elegant equations, of symmetry as beauty, of simplicity as art. Gravastars would force us to embrace a different kind of beauty, the beauty of incompleteness. They are not elegant in the way of clean solutions. They are elegant in their defiance of closure. Their shells and hollows embody an unfinishedness, a refusal to resolve into neat answers. This, too, is beautiful. The reminder that perfection can be found not only in clarity but in mystery. And what of human life? Gravastars, in their hollowness, mirror something within us. We, too, are defined not only by what is present but by what is absent. Our identities are shaped by questions we cannot answer, by longings we cannot name, by silences that define us as much as words. Gravastars would become metaphors for the human spirit, fragile shells around inner mysteries, luminous on the outside, hollow but powerful within. Their beauty would remind us that to be human is also to be unfinished, to live with ambiguity, to seek meaning in emptiness. In art galleries of the future, one might find installations inspired by gravastars. Dark rooms with glowing edges, soundscapes of echoes fading into silence, sculptures of shells that reveal voids inside. In literature, gravastars might become the symbols of characters who hide truths, of civilizations that wear masks, of societies balanced between collapse and creation. In philosophy, they would embody the paradox of identity itself, that we are both full and hollow, both fragile and powerful, both visible and hidden. And perhaps, most importantly, gravastars would change how we see our place in the cosmos. Not as insignificant creatures in a cold universe, but as participants in a story of beauty written in paradox. Gravastars tell us that even the most terrifying phenomena can carry elegance, that even emptiness can hold meaning, that even destruction can conceal creation. This is not beauty that comforts. It is beauty that challenges, that expands, that deepens our sense of what it means to be alive beneath the stars. In the end, gravastars will not only change physics, they will change aesthetics. They will redefine what we call beautiful, what we call sublime, what we call meaningful. They will remind us that art and science are not separate, but twin responses to the same mystery. And as we continue to study them, to imagine them, to weave them into our stories, gravastars will teach us that the hollow can be full of wonder, that the void can be luminous, and that the universe itself is the greatest artwork of all, signed not in ink, but in light, shadow, and silence. The question of endings has always haunted humanity. From the myths of ancient cultures to the models of modern cosmology, we ask the same thing. How will it all conclude? Will the stars fade into darkness, leaving behind an eternal winter of silence? Will the universe collapse in fire, returning to the density from which it was born? Or will expansion rip apart every structure, every atom, leaving only scattered radiation in a void without memory? These are not just scientific scenarios. They are existential symphonies, movements in the grand music of the cosmos. For decades, cosmologists have debated three great finales: the Big Freeze, the Big Crunch, and the Big Rip. Each offers its own narrative of silence, collapse, or tearing apart. But gravastars, if they are real, complicate this cosmic score. They suggest that the universe's future may not be so simple. Instead of marching toward one final note, reality may be composed of overlapping melodies, each gravastar a hidden instrument playing its part. In the Big Freeze scenario, galaxies drift apart until their light no longer reaches one another. Stars exhaust their fuel, black holes evaporate, and all that remains is a thin mist of particles in endless darkness. But gravastars would alter this image. Unlike black holes, which slowly vanish through Hawking radiation, gravastars might persist as stable shells for unimaginable spans of time. In the fading universe, they could become the last beacons, hollow stars holding vacuum energy within them, glowing faintly with potential even as everything else fades. They would outlast suns, galaxies, even the memory of light, their silence a reminder that emptiness itself can endure. In the Big Crunch scenario, expansion halts and reverses, the universe collapsing back into itself. Black holes would merge, matter would compress, and time would spiral into a singular end. Gravastars, however, resist singularities. If they are the universe's way of avoiding infinities, then perhaps the final collapse would not produce a singular point but a chorus of gravastars, hollow shells merging, rupturing, creating pockets of new physics. The end would not be a final collapse but a transformation, a transition into structures we cannot yet imagine. In this symphony, gravastars would be the percussion, pounding against the inevitability of singularity, turning finality into metamorphosis. The Big Rip is perhaps the most terrifying. Dark energy, instead of remaining constant, grows stronger, tearing galaxies apart, then stars, then planets, then atoms themselves. In this vision, nothing survives. Even the building blocks of matter are stretched into non-existence. But gravastars, with their cores of vacuum energy, could play a unique role here. They might amplify this ripping, serving as accelerants of expansion, their ruptures sending shockwaves of dark energy into an already fragile cosmos. Or perhaps they would resist, their shells containing energy even as everything else unravels, islands of structure in a sea of disintegration. In either case, gravastars would become central actors in the drama, their hollow interiors resonating with the fate of space-time itself. But what if none of these models is complete? Gravastars suggest another possibility, that the universe does not end at all, that within the hollows of these objects lie seeds of new beginnings. If ruptured gravastars can spawn new universes, then our cosmos may be only one verse in an infinite song, each universe giving rise to the next. In this scenario, the end is never truly an end. It is a handoff, a continuation, a passage of the cosmic melody into a new key. The symphony does not stop. It modulates endlessly across scales of reality beyond our comprehension. For us, this perspective is both terrifying and comforting. Terrifying because it means we may never have final answers, never see the true conclusion of the cosmic story. Comforting because it means that endings are not voids but transitions, that silence may lead to echoes, that death may conceal rebirth. Gravastars embody this ambiguity, reminding us that the universe prefers transformation to termination. Philosophically, this forces us to reconsider what we mean by the end of time. If gravastars can spawn new universes, then time itself may not end, but branch. Each rupture creates a new arrow of time, a new flow, a new narrative. Our own timeline may be only one branch among countless others, seeded by an object that collapsed eons ago in a universe long forgotten. In this view, gravastars are not just astrophysical anomalies. They are cosmic composers, writing the rhythm of time itself. For humanity, living under this awareness would be profound. We would no longer think of the cosmos as a story with a beginning and an end. Instead, we would see it as a symphony without conclusion, a composition that evolves, transforms, and continues across universes. Our role within it would not be to seek the final note, but to listen for our part in the ongoing melody. Gravastars would teach us to hear the hollow notes as essential, to recognize that even silence carries music. And perhaps this is their most haunting lesson, that beauty, meaning, and destiny are not found in finality but in continuation. That the hollow stars above us are not only warnings of collapse but invitations to wonder. That the universe, like music, does not require an end to be profound. So when we gaze at the night sky, let us imagine it not as a canvas destined for silence, but as a score still being written. Each galaxy a phrase, each star a note, each gravistar a rest that reshapes the rhythm. And if the universe is indeed a symphony, then gravastars are the pauses that make the melody possible, hollow, silent, terrifying, and yet essential. Because in the end, or rather in the endlessness, gravastars remind us that the cosmos is not moving toward silence, but toward transformation. And that, perhaps, is the most profound ending of all. The discovery that there is no end, only the hollow echo of a song that will play forever. Every civilization, from the smallest tribe to the largest empire, has built its worldview on symbols. The sun, the ocean, the mountain, these were not just features of the world, but anchors for meaning. They gave structure to myths, to religions, to philosophies. They told people who they were, how to live, and what to expect from the universe. As humanity becomes a cosmic species, our symbols must also grow. Gravastars may one day be among them. They are more than astrophysical conjectures. They are metaphors incarnate. Masks in the sky, hollows filled with energy, thresholds between destruction and creation. As black holes once became the emblem of finality, gravastars could become the emblem of ambiguity. They would represent the paradoxes of existence, the fragility of shells, the hidden power of emptiness, the uncertainty of endings. Future civilizations might look to gravastars not only for scientific insight but for philosophical guidance, seeing in them a mirror of their own struggles with knowledge, survival, and identity. Imagine a culture of starfarers who live in orbit around distant suns. To them, gravastars might become sacred objects, cosmic temples of uncertainty. They could symbolize the balance between risk and resilience, reminding colonists that even the most familiar shadows may conceal surprises. Festivals might be held in their honor, not out of worship, but out of reverence for mystery. Stories would grow around them, tales of hollow suns that whispered truths, of masks that protected deeper realities, of civilizations that thrived because they learned not to trust appearances. Politically, gravastars could reshape ideology. Just as the atom became a symbol of both destruction and progress in the 20th century, gravastars could become the emblem of choice and consequence in the 30th. Leaders might invoke them to caution against arrogance, to remind societies that the cosmos does not yield easily to certainty. Remember the hollow stars. They might say, as warnings against dogma, against assuming knowledge is complete. Gravastars would become arguments for humility written into the language of politics and philosophy alike. Technologically, they would embody thresholds. For engineers and scientists, gravastars could symbolize the pursuit of the impossible, extracting meaning from hollowness, power from voids, certainty from ambiguity. Research institutions might take their names from them, as universities once did from ancient gods. The Gravastar Institute could become synonymous with pushing beyond boundaries, with daring to study what seems untouchable. But their greatest impact may be spiritual. Humanity has always longed for symbols that unite opposites: life and death, chaos and order, nothingness and being. Gravastars embody that union in physical form. They are death that contains rebirth, void that contains energy, silence that contains echoes. Future civilizations could see them as reminders that the universe is not divided into simple categories, but layered with paradox. To meditate on a gravastar would be to meditate on the nature of existence itself: fragile, hollow, powerful, and mysterious. Even art and language would transform. New idioms might emerge. To walk the shell of a gravastar could mean to live on the edge of uncertainty. Poets could call themselves singers of hollowness, drawing on the image of shells resonating with unseen echoes. Architects might design buildings with hollow cores, glowing perimeters, and fragile shells, inspired by the gravastar's form. In this way, the concept would permeate not just science but the very fabric of cultural expression. What makes gravastars so potent as symbols is their refusal to resolve. They are not answers. They are questions. They remind us that the universe is not only made of certainties, but of ambiguities that must be lived with, not erased. This makes them perfect archetypes for a cosmic civilization, one that must navigate the unknown, balance danger with wonder, and accept that the truth often hides behind masks. And perhaps gravastars will become, for our descendants, what the compass once was for sailors: a guiding metaphor. Not pointing north, but pointing inward toward humility. Not guiding across seas, but across mysteries. They will teach that to navigate the cosmos is to embrace not just knowledge, but uncertainty. That the greatest strength of a civilization is not its mastery of nature, but its ability to wonder at it. In the end, gravastars may serve a role larger than their physics. They may become the archetypes of our cosmic identity. For a species stepping into the stars, they will be reminders that the universe is not obliged to reveal itself fully, that masks are as much a part of reality as faces, that hollowness can be as powerful as fullness. They will tell us that to be truly cosmic is not to conquer, but to question, not to dominate, but to listen. And as humanity evolves into a civilization among the galaxies, gravastars will whisper to us from the shadows that the greatest truths are often hollow, that endings are thresholds, and that meaning itself is forged not in answers, but in mysteries we dare to carry with us. Science is often portrayed as a journey towards certainty. Textbooks present discoveries as if they were final, neat, and complete, equations sealed, truths revealed. But in reality, science is not a monument. It is a conversation. Every answer generates new questions, and every question deepens the mystery. Gravastars, if they exist, embody this truth more vividly than almost any other idea in modern physics. They are reminders that the cosmos is not a puzzle to be solved, but a riddle to be lived with. For centuries, black holes were thought of as endpoints, singularities where our equations collapsed into infinities. They were the ultimate walls in the architecture of knowledge. Gravastars challenge that finality. They whisper that what we thought was an ending may in fact be a disguise. If black holes represent answers that overwhelm us, gravastars represent questions that invite us forward. They take certainty and hollow it out, leaving behind space for wonder. This shift has profound consequences for the culture of science. Instead of pursuing absolute truths, we begin to recognize the value of ambiguity. A gravastar cannot be neatly categorized. It is neither star nor hole, neither death nor birth. It exists in between, in the territory of paradox. To study it is to accept that science thrives not on finality, but on thresholds, on edges where ideas blur, where definitions collapse, where mystery is not a failure but a feature. This is not a weakness, it is a strength. For history shows that the greatest revolutions in science arose from anomalies. The orbit of Mercury didn't fit Newton's equations. It gave us relativity. The ultraviolet catastrophe defied classical physics. It gave us quantum mechanics. The expansion of the universe contradicted expectations. It gave us cosmology as we know it. Gravastars may play the same role, anomalies that force us to expand science beyond its current borders. They are not the defeat of knowledge, but its next frontier. And this realization changes how we see the scientific enterprise itself. Too often, we think of science as the accumulation of facts, as if the universe were a book and we are simply turning pages. Gravastars reveal that the book may never end, that its pages are infinite, that every chapter is rewritten by the questions we dare to ask. Science becomes less like reading and more like music, an improvisation, a symphony that evolves as it plays. Gravastars are one of its dissonant chords, reshaping the melody, daring us to listen more closely. Imagine the effect on education. Instead of teaching science as static, future generations could learn it as dynamic. Gravastars would be the perfect case study, an idea that resists closure, that shows students the beauty of uncertainty. They would learn that to be a scientist is not to possess answers but to dwell in questions. That the mark of intelligence is not certainty, but curiosity. Gravastars would remind us that awe is not the opposite of knowledge. It is its beginning. This reorientation would also affect how science interacts with society. If we accept gravastars as archetypes of uncertainty, we might learn to communicate science not as a collection of settled truths, but as an evolving story. Public trust in science often falters when discoveries change, when yesterday's certainty becomes today's revision. Gravastars could help us embrace change as natural. They could teach us to see revisions not as failures, but as growth, as signs that the universe is still speaking and that we are still listening. On a deeper level, gravastars force us to reconsider the relationship between science and philosophy. For centuries, philosophy asked the big questions. What is time? What is space? What is nothingness? Physics took over those questions, grounding them in equations. But gravastars return us to the borderland. They sit at the intersection of physics and metaphysics, of mathematics and meaning. To study them is to realize that the division between science and philosophy is artificial. The cosmos does not recognize our academic categories. Gravastars remind us that knowledge is whole, that questions of being, identity, and destiny belong as much to physics as to philosophy. This has implications for our future as a species. A civilization that values only answers may stagnate once those answers feel sufficient. A civilization that values questions, however, will never stop growing. Gravastars could become symbols of that orientation, the scientific equivalent of open doors. They tell us that no matter how much we know, there will always be more hidden behind masks. They encourage us to seek not finality but continuity, not closure but curiosity. And perhaps this is their greatest lesson. Gravastars are hollow, but their hollowness is not empty. It is filled with potential, with mystery, with possibility. In the same way, science may appear hollow when it cannot provide closure. But that hollowness is fertile ground, the place where wonder grows. Gravastars teach us that the value of science is not in its ability to end questions, but in its ability to keep them alive. For humanity, this lesson may be transformative. In a future where we journey among the stars, where we face challenges of survival and meaning, we will need not only knowledge but imagination. Gravastars could become our cosmic teachers, reminding us that survival requires curiosity, that progress requires humility, that the universe will always be larger than our certainties. They will remind us that to be human is not to know everything, but to ask endlessly. And so, gravastars turn science itself into an art. The art of living with ambiguity. The art of listening to echoes. The art of finding beauty not in answers, but in mysteries that refuse to resolve. They show us that the hollow is not void, but invitation. And if we accept that invitation, we will discover that science is not about conquering the unknown, but about dwelling within it, with wonder, with courage, and with joy. Because in the end, gravastars remind us of the greatest scientific truth of all, that the universe is not obliged to be simple, and that our role is not to finish its story, but to keep reading, keep listening, keep asking. For most of human history, reality seemed simple. What we saw was what existed. The sky was a dome, the stars were lights, the earth was solid beneath our feet. Only slowly did we learn that appearances deceive. The stars are suns unimaginably far away. The earth itself is in motion, spinning and circling the sun. And the solid ground beneath us is not solid at all, but a lattice of atoms mostly made of empty space. Reality has always been layered. Gravastars may be the latest and perhaps most unsettling reminder of this truth. On the surface, they wear the mask of black holes. Their gravity bends light in familiar ways. Their silhouettes mimic the darkness we have come to expect. They hide behind shadows, indistinguishable from what we think we know. But behind that mask lies hollowness, a vacuum core surrounded by a fragile shell of exotic matter. The disguise is perfect, and that perfection forces us to ask, if the universe can hide gravastars in plain sight, what else might it conceal? This is not merely an astrophysical question. It is a philosophical one. Gravastars suggest that reality itself may be structured in layers of masks, that what we perceive is only a surface, beneath which lie deeper truths, truths that may contradict our assumptions entirely. The cosmos may not present itself honestly. It may prefer to mislead, to cloak, to challenge. Gravastars are evidence that appearances cannot be trusted, even when backed by decades of scientific observation. This realization echoes in human history. Every great shift in knowledge has come from lifting a mask. The Earth is not the center of the universe. Light is not continuous but quantized. Space is not empty but dynamic. Gravastars could be the next mask to fall, revealing that even the most iconic of cosmic monsters, the black hole, is not always what it seems. Reality itself is a trickster, wearing costumes to test our imagination. And here lies the unsettling implication. Perhaps the mask is the essence, not the illusion. Perhaps reality is not a solid truth waiting to be uncovered, but a series of layers, each as real as the one before, each only part of the whole. Gravastars embody this idea. They are not false black holes. They are true gravastars. Both layers exist, both are real, and the difference lies in perspective. To one observer, a gravastar is indistinguishable from a black hole. To another, with deeper knowledge, it is something else entirely. Reality shifts depending on how much of the mask we manage to lift. This understanding transforms our relationship with the cosmos. Instead of expecting final answers, we begin to expect illusions. We begin to see mystery not as an exception but as the rule. Gravastars show us that the universe is not a clean stage where truths are revealed one by one, but a masquerade, where truths dance behind veils, never fully unveiled. To study reality is not to strip away masks until only the truth remains, but to recognize that the masks themselves are part of the truth. In this light, science becomes not the removal of illusions, but the navigation of them. Gravastars remind us that appearances are not lies, but partial truths. A black hole is real, and yet sometimes it may be something else. The mask does not negate the face. It enriches it. Reality is not binary, true or false, real or illusion. It is layered, contextual, perspectival. Gravastars teach us to hold multiple truths at once, to accept paradox as part of the fabric of existence. And perhaps this lesson reaches further than physics. Human life, too, is filled with masks. We wear identities, roles, appearances. We show fragments of ourselves to the world while hiding hollowness within. Like gravastars, we are shells containing mysteries. What seems final from the outside is rarely the whole story. Gravastars mirror this human condition, magnifying it to a cosmic scale. They remind us that the search for reality is also the search for ourselves, and that both are built from layers we may never fully uncover. Future civilizations may take this philosophy to heart. They may grow up not expecting certainties, but embracing multiplicities. Gravastars could become archetypes of layered truth, symbols of the masquerade of existence. Schools might teach them not only as astrophysical objects but as philosophical lessons. Remember the hollow stars, what you see may not be what is. Such a perspective would prepare humanity for life among the galaxies, where survival depends on humility before the unknown. And perhaps, in the deepest sense, gravastars are clues to the nature of the universe itself. If reality is a masquerade, then perhaps the cosmos is structured not as a simple equation but as a play of masks, each layer a performance that reveals and conceals. The vacuum energy inside gravastars could be seen as the stage machinery behind the show, invisible but essential. The shell is the mask, the core is the script. Together they create the illusion we call reality. In this way, gravastars force us to confront the possibility that there is no final unveiling, that the masks will always remain, one after another, infinite in number, that truth itself is not a destination but a performance, unfolding endlessly. For some, this is unsettling. For others, it is liberating, because it means that the universe will never run out of wonder, that there will always be another mask to lift, another mystery to pursue, another gravastar hidden in the dark. And so, gravastars are not just astrophysical anomalies. They are symbols of the nature of reality. They remind us that the universe is not obliged to be transparent, that truth comes in layers, that appearances can be both real and deceptive at once. They show us that existence is not a single face but a masquerade, and that to live within it is not to seek an end to masks, but to dance with them, to marvel at them, to let them teach us humility and awe. Because in the end, gravastars do not simply challenge our science. They challenge our philosophy of being. They tell us that the cosmos itself wears masks, and that the masks are not illusions to be discarded, but revelations to be embraced. To dream of traveling between the stars is to dream of leaving behind the familiar. New suns, new worlds, new dangers, new wonders. Each step outward multiplies both risk and possibility. Humanity has always been a migratory species, restless and curious. But as we imagine the leap from interplanetary to interstellar, we must accept that the universe is not a quiet ocean. It is an ocean with storms, currents, and hidden reefs. Gravastars, if they exist, may be among the most treacherous and enigmatic of those hazards. For navigators of the future, black holes will already pose challenges. Their gravity can bend flight paths. Their accretion disks can bathe ships in radiation. Their very presence warps time. But black holes are at least predictable. Gravastars would not be. Their shells of exotic matter, their potential for instability, their hollow cores of vacuum energy. These features could make them volatile neighbors. A ship passing too close might not simply be pulled in. It could be battered by unpredictable outbursts, by eruptions of energy that no chart can anticipate. This unpredictability would shape the very philosophy of navigation. Starfarers would not only map gravastars as obstacles, they would treat them as cosmic boundaries. Routes would be planned to avoid their silent masks. Spacefaring civilizations might adopt rituals of respect, as ancient sailors did with treacherous seas. Gravastars would become both practical dangers and symbolic reminders that the cosmos is never fully charted and that arrogance can be fatal. Yet danger is not the whole story. Gravastars may also hold opportunity for interstellar explorers. If their vacuum cores truly store vast reservoirs of energy, advanced civilizations might learn to tap them. Outposts could be built in cautious orbit, harvesting energy from the hollowness within. To a civilization that spans light years, such energy sources would be priceless. Gravastars might become the refueling stations of the deep cosmos, terrifying to approach, but essential for survival. This dual nature, danger and opportunity, is what would make gravastars central to the philosophy of interstellar travel. They would symbolize the necessity of humility. No matter how advanced a civilization becomes, the cosmos will always hold mysteries beyond control. Gravastars remind us that exploration is not conquest but negotiation, not mastery but dialogue. To journey among the stars is to live beside enigmas, to accept that some shadows are not meant to be pierced, at least not yet. And what of contact with other civilizations? Here, too, gravastars would shape philosophy. If we ever meet beings from other star systems, we will need common ground, metaphors, symbols, shared experiences. Gravastars could provide that. Any civilization with advanced astronomy would know of collapsed stars. Any civilization aware of gravastars would share the same questions, the same awe, the same fear. They could become universal symbols, a kind of cosmic language spoken across species. The hollow stars would remind us all that the universe hides truths, that knowledge is fragile, that humility is necessary. Perhaps gravastars could even become meeting places. Imagine future civilizations arranging encounters in orbit around one, each recognizing the symbolism of the site. A gravastar, dark and silent, would hang between them, not as a resource to be claimed, but as a reminder of shared vulnerability. In its hollow core, they might see a metaphor for dialogue. Two shells meeting across emptiness, searching for meaning in silence. Gravastars could teach us that contact is not about domination but about recognition of the masks the cosmos wears and the masks we wear ourselves. Culturally, this would be profound. Humanity has always defined the other, the foreign, the alien, as a mirror of itself. Gravastars would expand that mirror to a cosmic scale. They remind us that we, too, are explorers staring at shadows, uncertain of what lies inside. Another civilization would face the same uncertainty. Gravastars could become the symbols of empathy across species, teaching us that all intelligence in the universe shares the same struggle, to live with questions too vast to answer. Philosophically, gravastars might alter our approach to diplomacy. If we recognize that the universe itself is unpredictable, then we might approach others with more caution, more patience, more humility. The masks of the cosmos teach us to be wary of assumptions. In the same way, contact with another intelligence would demand restraint, openness, and a willingness to accept ambiguity. Gravastars would remind us that certainty is dangerous, and that wisdom lies in listening. And perhaps, on an even deeper level, gravastars would shape the identity of a spacefaring humanity. We would see ourselves not as conquerors, but as participants in a shared cosmic drama. We would recognize that survival is not about control but about adaptation. Gravastars would be constant reminders of our fragility and of our resilience. They would teach us that to travel among the stars is not only to cross distance, but to grow in perspective. In the end, gravastars would become landmarks of philosophy as much as navigation. They would mark the places where certainty collapses, where mystery reigns, where humility is demanded. For interstellar civilizations, they would be both danger and guide, obstacle and teacher. And for humanity, they would remind us that the greatest discoveries are not only about what lies outside us, but about how we choose to respond, with fear, with arrogance, or with wonder. Because in the silence of gravastars lies not only the echo of physics, but the promise of wisdom. They tell us that the universe is larger than any map, that contact with the unknown requires humility, and that the journey to the stars is as much about who we become as about where we go. Every generation of humanity has looked at the sky and asked the same questions. Why are we here? Where are we going? What will remain when we are gone? For millennia, those questions found answers in myth, in religion, in philosophy. But as our telescopes pierced the darkness and our equations mapped the cosmos, the same questions grew larger. The universe became our mirror. And now, with the idea of gravastars, that mirror reflects something both terrifying and profound. That even endings may not be what they seem, and that the search for meaning may be written not in certainty, but in ambiguity. To imagine a gravastar is to imagine destiny itself transformed. For centuries, death has been the great finality. for stars, for civilizations, for individuals. Black holes embodied this finality perfectly. Regions of no return, places where even light is imprisoned, symbols of silence without escape. Gravastars change the story. They suggest that death itself may be a mask, that the collapse of a star may not lead to an absolute ending, but to a hollow form filled with strange energy, carrying within it the possibility of transformation. For humanity, this resonates deeply. We live with the awareness of mortality. Every culture invents stories to soften the silence at the end of life. Heavens, reincarnations, eternal returns. Gravastars embody this impulse in astrophysics. They are not the erasure of existence, but its reshaping. They remind us that endings may hide continuities, that silence may echo, that even in collapse there may be hidden futures. To contemplate gravastars is to contemplate our own mortality through the lens of the cosmos. Imagine what this would mean for human destiny. If the universe itself avoids singularities, refusing to collapse into infinities, then perhaps our own fate is not as final as we fear. Perhaps life, consciousness, civilization, even when they appear to end, are part of cycles larger than we can see. Gravastars hint at a universe that transforms rather than terminates, that recycles rather than erases. They encourage us to see death not as void but as passage, not as final silence but as hollow space where new echoes may arise. In this sense, gravastars could reshape our philosophy of time. Instead of imagining a straight line from birth to death, we might begin to imagine a continuum, where endings open into beginnings, where hollowness is fertile, where silence conceals music. This is not merely poetic comfort. It is scientific humility. The cosmos has shown us again and again that what we thought were ends, the edge of the earth, the death of stars, the limits of matter, are thresholds. Gravastars may be the next threshold, teaching us that time itself may be more recursive, more cyclical, more open-ended than we ever dared to believe. For future civilizations, this awareness could transform destiny. A species that sees endings as absolute may live in fear, hoarding, fighting, clinging to survival. A species that sees endings as thresholds may live differently, with more courage, more openness, more wonder. Gravastars could inspire this transformation. They would remind us that the cosmos itself is built not on conclusions but on continuities. They would encourage us to live as though our destiny is not to vanish, but to echo, to transform, to contribute to a larger rhythm. Culturally, gravastars would become metaphors for human fate. Artists might paint them as symbols of rebirth. Poets might write of hollow suns that carry memory into the future. Philosophers might compare them to the human soul, fragile on the outside, filled with mystery within. Religions might see in them confirmation of eternal cycles, of life after death, of universes birthing from silence. Gravastars would enter our mythology as cosmic reflections of the oldest human longing, to know that existence does not simply end. Yet their message is not simple comfort. Gravastars also embody danger. Their shells can rupture, their cores can destabilize, their hollowness can unleash destruction. In this way, they remind us that destiny is not guaranteed, that transformation can be violent, that continuities are not always gentle. They challenge us to accept not only the possibility of rebirth, but also the reality of risk. Human destiny, like gravastars, may be hollow and fragile, balanced between collapse and renewal. To survive, we must learn to live with that fragility and to find meaning within it. This brings us to the deepest resonance of gravastars. They mirror the human condition. We too are shells around mysteries. We too wear masks, hiding hollowness that is not empty but full of potential. We, too, live between certainty and ambiguity, between fear of endings and hope for continuities. Gravastars magnify our own experience to a cosmic scale. They tell us that our fate, like theirs, is not a simple descent into silence, but a journey through thresholds we cannot yet imagine. And perhaps this is the true destiny gravastars reveal, that humanity's role in the universe is not to solve the mystery, but to participate in it, to live with questions, to marvel at masks, to accept that meaning is not fixed but evolving. Gravastars remind us that destiny is not a final point, but a hollow space we fill with wonder, courage, and imagination. So when we look at the night sky, when we wonder about the fate of the stars and the fate of ourselves, gravastars whisper a lesson. That endings are not what they seem, that hollowness can hold eternity, and that destiny is not silence but transformation. They tell us that human life, like the cosmos, is not about reaching a conclusion. It is about becoming part of a larger symphony, one that plays on long after we are gone. Because in the end, gravastars are more than astrophysical hypotheses. They are mirrors of our own longing, our own fragility, our own hope. They show us that destiny is not written in certainty, but in questions, and that perhaps the greatest destiny of all is to keep asking, even as the hollow stars watch silently from the dark. Every civilization at its height has sought a unifying vision. The ancients wove myths that bound sky and earth together. The Enlightenment sought harmony between reason and nature. The modern age built its worldview around science, technology, and progress. But as humanity peers deeper into the universe, we find ourselves at another threshold. Gravastars, if they exist, may become symbols of a new synthesis, a philosophy that unites science, art, and spirituality in a shared understanding of reality. Why? Because gravastars are more than astrophysical hypotheses. They are metaphors of paradox. They are shells that hold hollowness, masks that conceal energy, boundaries that separate destruction from creation. They force us to confront the fact that the universe itself is layered, ambiguous, and symbolic. Science explains their mechanics, but it cannot exhaust their meaning. Art captures their mystery, but it cannot define their physics. Spirituality senses their resonance with ancient archetypes, but it cannot replace mathematics. Gravastars demand all three: knowledge, imagination, and reverence. In science, they are anomalies that challenge our frameworks. They defy the neat equations of black holes, offering instead hollow interiors filled with vacuum energy. They force us to rethink the end states of stars, the role of dark energy, the nature of spacetime. They are test cases for the next physics, the elusive bridge between relativity and quantum mechanics. Gravastars remind scientists that nature is cleverer than our equations, and that humility is the first principle of discovery. In art, they are emblems of ambiguity. Painters might depict them as glowing shells around perfect voids, symbols of hidden truths. Poets might describe them as hollow suns that whisper in silence. Musicians might write symphonies echoing their imagined gravitational reverberations. Gravastars remind artists that beauty is not only harmony, but tension, not only light, but shadow, not only presence, but absence. Their hollowness becomes a canvas for the human imagination, a metaphor for the mysteries we carry within ourselves. In spirituality, they resonate with archetypes as old as humanity. Cultures across the world have spoken of death that conceals rebirth, of emptiness that contains fullness, of thresholds that transform rather than end. Gravastars embody these archetypes in astrophysical form. They are the cosmic chrysalis, the shell that holds metamorphosis, the mask that hides transformation, the hollow that conceals eternity. For spiritual seekers, gravastars might symbolize the unity of science and mystery, proof that the deepest truths are not contradictions but paradoxes. The synthesis of these perspectives could form a new cosmic philosophy. Imagine a worldview in which gravastars are not just objects in space, but teachers of being. Science would tell us how they form. Art would show us how they feel. Spirituality would remind us what they mean. Together, they would create a vision of humanity as part of a layered cosmos, a universe that speaks in equations, in metaphors, and in mysteries. Such a philosophy would transform culture. Education would teach gravastars not only in physics classes, but in literature and philosophy. Students would learn that knowledge has multiple dimensions: analytical, creative, and contemplative. Public discourse would embrace uncertainty not as weakness, but as wisdom. Gravastars would become cultural symbols of humility, resilience, and imagination, guiding humanity toward a civilization that thrives not on certainty, but on curiosity. This cosmic philosophy would also reshape our sense of meaning. Too often, science and spirituality are cast as opposites, one seeking facts, the other seeking purpose. Gravastars reveal that the two can converge. Facts themselves can carry meaning, and mysteries themselves can inspire awe. A civilization that embraces this unity would no longer divide knowledge from wonder or explanation from beauty. It would see them as complementary ways of engaging with the same reality. And perhaps this is the destiny of humanity, to evolve from a species that divides its knowledge into categories, into one that sees wholeness in ambiguity. Gravastars may be the catalysts of this shift. They are reminders that the universe is not neat, that its truths come layered, that its meaning is richer than any single discipline can capture. They invite us to build a worldview as complex as they are, scientific in rigor, artistic in imagination, spiritual in humility. For the cosmos itself is all three. It is measurable, beautiful, and mysterious. Gravastars embody this triad perfectly. To ignore any one perspective would be to miss their essence. To embrace all three would be to move closer to a philosophy worthy of a cosmic civilization. And so, Gravastars may one day stand as symbols of a new human era. An era where science no longer excludes art, where art no longer ignores science, where spirituality no longer fears discovery. An era where we see the universe not as a machine to be solved, but as a story to be lived. Gravastars, hollow yet full of meaning, would remind us that the most profound truths are paradoxes, and that wisdom lies not in resolving them, but in living within them. Because in the end, gravastars are not just astrophysical objects. They are invitations to think, to feel, to wonder, to build a civilization that does not fear mystery, but honors it. To weave a cosmic philosophy where science, art, and spirit are not enemies, but companions on the same journey. And if we accept that invitation, we may find that the hollow stars in the night sky are not only echoes of collapsing suns, but beacons guiding us toward a deeper wholeness, a vision of humanity finally at home in the layered, masked, mysterious universe it inhabits. Human history is filled with symbols of fear. Volcanoes, eclipses, storms, plagues, each brought terror, and each shaped how societies saw themselves. Yet, with time, many of these same forces became symbols of resilience and hope. The volcano that once destroyed a city became the fertile soil for a new civilization. The eclipse that terrified kings became a predictable marker of cosmic harmony. Humanity has always learned to transform its terrors into teachers. Gravastars, if real, may follow the same path. At first, they would inspire dread. To learn that some of the black holes we thought we understood might instead be unstable shells, capable of unpredictable eruptions, would unsettle even the most rational minds. The idea that the galaxy contains disguised catastrophes would add a new layer of existential anxiety. But with time, as we studied them, gravastars could shift from symbols of fear to symbols of resilience. They would remind us not only of danger, but of the strength to live with uncertainty. Because humanity's greatest strength has never been certainty. It has been adaptability. We survived ice ages, plagues, wars, and planetary shifts not by knowing everything in advance, but by adapting to what we could not control. Gravastars would extend this lesson to a cosmic scale. They would remind us that survival in the universe requires humility, vigilance, and cooperation. No nation, no individual, no generation could face such mysteries alone. They would force us to think as a species, united by shared vulnerability and shared wonder. In this sense, gravastars could become symbols of unity. Just as the first images of Earth from space, the pale blue dot, the fragile marble floating in darkness, shifted our sense of identity, the realization of gravastars could do the same. They would remind us that the dangers of the cosmos are not national, but universal. No border protects us from the mysteries of space-time. No wall can shield us from the silence of collapsing stars. Gravastars would push us toward global identity, forcing us to see ourselves not as fragmented societies, but as one civilization beneath the same hollow sky. Hope would come not only from unity, but from possibility. For gravastars, though dangerous, also carry promise. Their cores of vacuum energy may hold secrets to new physics, new energy sources, new ways of understanding the universe. If harnessed, they could power civilizations for eons. If studied, they could reveal the nature of dark energy, guiding us toward the ultimate laws of reality. Gravastars embody the paradox of the cosmos, that the same phenomenon that terrifies can also enlighten. They remind us that hope is often hidden in the very places we fear to look. Culturally, this would reshape our symbols. Where once we painted black holes as monsters of silence, gravastars might be painted as lanterns of ambiguity. Frightening, yes, but also filled with potential. They could inspire art that celebrates resilience, music that echoes with their imagined reverberations, literature that uses them as metaphors for hidden hope. In classrooms, children might learn that gravastars are not only dangerous, but also invitations to courage. That to live in a universe with hollow stars is not to despair, but to wonder. Philosophically, gravastars would deepen our understanding of hope itself. Hope is not certainty that things will end well. It is courage to face uncertainty with imagination. Gravastars teach us this lesson on a cosmic scale. They are shells that may rupture, but they are also shells that may hold eternity. They are shadows that may conceal destruction, but they are also shadows that may conceal creation. Hope lies not in erasing the danger, but in embracing the paradox, in recognizing that meaning emerges not from certainty, but from resilience in the face of the unknown. Politically, this could inspire cooperation. Nations might realize that studying gravastars requires collective effort. Shared telescopes, shared data, shared missions. Just as climate change forced us to confront the reality of planetary unity, gravastars could force us to confront cosmic unity. They would become symbols of cooperation, reminders that the universe itself demands collaboration. For if we cannot unite even in the face of stars, how can we hope to thrive among them? Spiritually, gravastars might become emblems of transcendence. They would echo ancient teachings that emptiness is not void but fullness, that silence is not absence but potential, that death is not end but transformation. In their hollowness, believers of many traditions could find metaphors for hope beyond endings. Gravastars could become universal symbols of the human spirit, fragile, hollow, but capable of carrying infinite meaning. And in this way, gravastars would shape humanity's future destiny. As we step into the cosmos, building ships to cross between stars, we will need more than engines and equations. We will need stories that unite us, symbols that guide us, hopes that sustain us. Gravastars could be among those symbols. They would remind us that even the most terrifying mysteries of the universe carry within them the seeds of meaning, the possibility of unity, the spark of hope. So when our descendants look at the night sky, charting their paths among the stars, gravastars may be the markers they remember, not only as dangers to avoid, but as beacons of resilience, as teachers of humility, as emblems of unity. They would tell us that hope is not found in certainty, but in the courage to live with the hollow unknown. Because in the end, gravastars are more than hollow stars. They are mirrors of ourselves, fragile, unpredictable, mysterious, yet capable of carrying hope across the silence of the cosmos. Science has always been more than numbers. It is a cultural force. The telescope was not just an instrument, it was a new way of seeing the world. The discovery of electricity was not just a technical advance. It rewired the imagination of an entire age. The space race was not only about rockets, it was about identity, pride, and hope. Gravastars, if they are proven real, could carry this fusion of science and culture into a new epoch. Because gravastars are not just objects for physicists. They are metaphors, stories, inspirations. They bridge the gap between the measurable and the meaningful. Their hollowness speaks to our imaginations as powerfully as their physics speaks to our instruments. This duality, fact and symbol, is what makes them so powerful. They belong not only to science, but to culture. Every great discovery begins as a story we tell ourselves. Copernicus told us a story about Earth moving around the sun. Darwin told us a story about life evolving through natural selection. Einstein told us a story about time and space bending with gravity. Gravastars would tell us a new story, that what we see as final may only be disguise, that endings may be hollow beginnings, that the universe wears masks more intricate than we ever imagined. And like all stories, this one would shape culture. It would appear in classrooms, where children learn that the cosmos itself thrives on paradox. It would appear in media, where gravastars become symbols of hidden truth. It would appear in philosophy, where they challenge ideas of reality and illusion. Gravastars would remind humanity that science is not only equations, but narratives that teach us who we are and where we belong in the cosmos. Artists have always been among the first to seize scientific ideas and translate them into symbols. Black holes became icons in films, paintings, and literature. Metaphors for despair, obsession, or infinity. Gravastars would inspire a new wave of artistic exploration. Painters might depict them as glowing halos around perfect voids. Architects might design structures that echo their geometry, shells of strength encasing emptiness. Musicians could compose soundscapes inspired by their imagined echoes in spacetime. In this way, gravastars would become cultural motifs, shaping aesthetics just as much as science. They would embody the tension between appearance and reality, fragility and power, silence and resonance. They would inspire creativity precisely because they resist definition. To portray a gravastar is to portray paradox itself. Gravastars would also echo with spiritual traditions. Across cultures, emptiness has been seen not as void but as potential, the womb of creation, the silence before the word, the chrysalis of transformation. Gravastars, hollow yet filled with dark energy, mirror these archetypes with uncanny precision. They would invite reflection not only on physics, but on meaning. Spiritual traditions might see in them confirmation that the cosmos itself is layered, that endings conceal beginnings, that silence carries presence. Thus, gravastars could become shared symbols across science, art, and spirituality, uniting disciplines often seen as separate. They would remind us that wonder is not divided, but whole, that truth speaks many languages: equation, image, and metaphor. Imagine how this might shape the future. Just as cathedrals once symbolized the unity of art, faith, and science in the Middle Ages, research stations around gravastars might serve as the cathedrals of a spacefaring age. Scientists studying their emissions, artists interpreting their mystery, philosophers contemplating their meaning, all working side by side. Gravastars could become the great cultural projects of tomorrow, uniting disciplines, nations, and generations in a shared pursuit of wonder. In schools, students might learn physics through art inspired by gravastars, or poetry through equations describing their shells. Museums could host exhibitions where science and creativity merge, showing visitors not only what gravastars are, but what they mean. Governments could fund missions not only for data, but for culture, recognizing that the pursuit of cosmic mystery is as much about identity as it is about knowledge. Ultimately, gravastars remind us that the universe is not the property of scientists alone. It belongs to everyone who wonders, who imagines, who searches for meaning. Their discovery would not end in academic papers. It would ripple outward into culture, shaping how humanity tells its story. They would become part of our shared legacy, just as constellations, myths, and music once were. And perhaps this is their deepest gift. Gravastars would show us that science is not separate from culture but at its heart. That equations and metaphors, telescopes and canvases, observatories and symphonies are all part of the same human project, to understand our place in the cosmos. Because in the hollow silence of gravastars lies not only physics, but poetry. Not only danger, but inspiration. Not only answers, but stories. They invite us to unite disciplines, to break down boundaries, to see knowledge as one. And in doing so, they may help us build not only a more advanced civilization, but a more imaginative, more unified, and more hopeful one. Time is the most intimate dimension of our lives. It beats in our hearts, it flows through our thoughts, it carries us from birth to death. And yet, time is also the most elusive of all mysteries. We feel it constantly, but we do not know what it is. For centuries, philosophers called it the river of becoming, the measure of change, the shadow cast by eternity. Physicists described it as absolute, then as relative, then as something bound up with space itself. Gravastars, if they exist, add yet another layer to this riddle. Because gravastars are paradoxes in space-time. Their dense shells slow time almost to a halt, just as black holes do. But inside their hollow cores, filled with vacuum energy, expansion may accelerate time, stretching it into new rhythms. They are arenas where two clocks tick against each other, one slowing toward silence, the other racing toward infinity. To approach a gravastar would be to stand in the tension between timelessness and eternity, caught in a place where the very concept of before and after begins to dissolve. This vision reshapes how we think of eternity. Eternity is often imagined as endless time, a line stretching without limit. But gravastars suggest something else. Eternity as layered, contradictory, hollow. Eternity as a mask behind which time itself transforms. Perhaps eternity is not the absence of time, but its constant metamorphosis. The silence that conceals echoes, the void that hides new beginnings. Gravastars embody this vision. They are not endless in the way black holes are, nor finite in the way stars are. They are thresholds where endings and eternities meet. For human culture, this would be transformative. Art would depict gravastars as symbols of temporal paradox. Glowing shells around voids, halos of stillness around centers of acceleration. Poets would write of the two clocks hidden in their cores. Philosophers would use them to describe the coexistence of mortality and immortality, of change and permanence. Spiritual traditions might find in them images of resurrection and rebirth, not as metaphors only, but as realities written into the cosmos itself. Gravastars would become our teachers of time, showing us that eternity is not beyond us, but within the very structures of the universe. And what of humanity's own relationship to time? Gravastars remind us that our clocks, our calendars, our lifespans are only local truths. On cosmic scales, time bends, stretches, contradicts itself. To live with this awareness is to live more humbly, to know that our sense of urgency and finality is but one rhythm among many. Gravastars tell us that the cosmos does not fear endings, because endings are always thresholds. Time does not run out, it reshapes itself. This awareness would ripple across every aspect of culture. In politics, it would encourage long-term thinking, planning not only for years but for centuries. In technology, it would inspire inventions designed to endure, to adapt, to transform with time. In philosophy, it would dissolve rigid concepts of finality. In art, it would inspire expressions of ambiguity, works that embrace contradiction rather than avoid it. Gravastars would not only change our science, they would change our culture of time itself. We began with fear. Gravastars were imagined as monsters deadlier than black holes, hollow stars that could rupture, devouring entire systems. But as we followed their story, we discovered something deeper. Gravastars are not merely dangers. They are mirrors. They reflect back to us our own fragility, our own masks, our own hollowness filled with questions. They have taught us that science is not the search for final answers, but the art of living with mysteries. That endings may be thresholds, that emptiness can hold energy, that silence can carry echoes. They have shown us that the universe itself is layered, masked, ambiguous, and that our role is not to strip away all the masks, but to marvel at them, to learn from them, to let them expand our imagination. Gravastars have reminded us that culture, too, is cosmic. Science, art, and spirituality are not separate paths but different ways of touching the same mystery. In the hollow stars, equations meet metaphors, and metaphors meet meaning. Gravastars tell us that the cosmos speaks in many languages, and that we must listen to them all if we wish to understand. And finally, they have offered us hope. Hope that even in endings there may be continuities. Hope that humanity, fragile as we are, can find unity in shared wonder. Hope that the hollow sky above us is not empty, but full of meaning waiting to be discovered. So, when you look up at the night sky, when you see the shadows of collapsed stars, Imagine that some of them may not be black holes, but gravastars. Imagine that behind their masks lies not only destruction, but transformation. Imagine that the universe itself is whispering through them. Endings are never the end. Emptiness is never empty. Silence is never silent. And in that whisper lies the most profound truth of all, that existence, like gravastars, is hollow only on the surface. Within, it is filled with echoes, with energy, with meaning, enough to carry us forward into the future, into the stars, into the endless mystery that is the cosmos.